In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up the ante, making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes in talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tone chuckle prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello everyone, welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
Hey, what's up, everybody?
Talking about some 0-point energy, because it's free.
It's free. Free energy. Free energy.
Oh, I love it, man. I absolutely love it. What's going on, guys? I'm in a good mood today. Oh, man, I'm feeling a lot better. Getting happier, that's for sure. So, how's your week going, Joe?
That's a week. Yeah, it's a week. Truth or a lie, you know what I mean? I'm gonna go to the mine tomorrow, though, so I'm happy about that. You know,
that's cool.
Yeah, get out there, do some more.
Dude, I like that mine. You got some good ones out of there, man. A lot of stuff to test with, a lot of things to hang on to.
I'm starting to accumulate, you know, like good test quality quartz. You know what I mean? Like a good amount of it. So keep on accumulating that while looking for the big stuff. You know, for the shelf queens over there, right?
Right on. All right, let's talk a little bit about a 0-point energy in there. Joe, I got a couple questions for you, okay?
All right.
Do you think the energy in the air higher than the atmosphere, that energy is 0-point energy?
No.
Okay. Why?
I mean, a loaded question. I mean, I think that it's all derived from. Actually, you know what? I take it back. Yes.
Yes.
Because
Okay.
see, it's all derived from the same source, right? But there is energy that exists, right, in our environment that has already come in through the 0-point source, and now it is in its state of dimensional diffusion or interaction or material coupling or storage, right? So there's all these different ways that we bring the energy in, and then it goes about into these other entropic processes. But yeah, I would guess so, because of the energy exchange at that point. Yeah.
I asked a question because they say 0-point energy is all around us. You know what I mean? We hear that a lot. A lot of people in the chat say it. So if we believe that, then we got to believe that the energy is in the sky. It's all around us. You know what I mean? As we talk, it's next to us. But I like you in the beginning, I look at it and I go, well, no, that's because it's a different process. It's tainted. And I say that in a way because, like you said, it could pick up a little more magnetism in it than what it originally had. That's changing the energy a little bit. You know what I mean? I don't know that the compression is going to change too much, but then again, when you get to the upper atmosphere, you get wind and stuff, and it changes some of it. So yeah, I mean, like you, I think the conditions are changing it a bit, but ultimately, all the energy in the world is completely the same. It is just an environmental change that
Right.
causes a condition in it, right?
Well, right, because of the energy exchange and the material coupling, it would make sense that in our most diffuse zones, you know, there would be, you know, a good amount of potential coming in at that point, and as it ultimately coalesces with our magnetic field, you know, because there's all these boundary zones that have to occur, right? As go out and band, because there is probably a definite point where our atmosphere ends and space begins, right?
Mm-hmm.
So even if it goes out into a state of diffusion, there's still going to be that line that exists.
Yes.
And that these are sort of the determining factors. All these different boundaries that you have. It's like when you had always talked about the Tesla coil. You step away, you start losing it, but then all of a sudden it'll light up again, and you start losing it, it'll light up again. Now it does get a little dimmer maybe each time as you ultimately move away from it, but you'll go through these phases of dimming, and then you'll get the brightness again because you're hitting a wall of that boundary zone. And I think that it's pretty much the same. You have all these different layers where the exchange rates are just simply different. And then there's the relationship with the solar energy, which is probably a more um, easy to understand form of 0 point energy. You know?
So I think there's a pure form of 0 point energy, and I think there's gradients everywhere. Okay, that's just the way I would say it.
Yeah.
So when we go to look for it and say we want to build it, right? You say, okay, so how do I start to build this thing? How do I know what it is? How do I know what to look for? What am I trying to achieve?
Right.
If we know that we're looking for a pure energy, okay, as pure as humanly possible, or earthly possible, if you want to say it that way, to getting a pure energy form, that would be 0 point. Would you agree with that?
Yeah, and I mean to build on that even just a little bit more because I think that it's a good point that you bring up. If you think about it as you know, bubbles within the bubbles and their pressure zones, right? So it's like I had said, I believe that the 0 point lies at the boundary of three-dimensional space and four-dimensional space. I mean, that's my opinion of it. And that 4D is fully permeating our reality, and that we create pressure on that boundary, and it's those pressures. But there's the bigger picture, right, that we're a part of. So you have the solar system, right, and that in itself is going to have its own bubble, so to speak, or pressure zone in its own gradient, but it's going to have its own definite boundaries. And then within it, you're also going to have these sub boundaries that are bubbles within the bubbles of pressure zones. And then because the boundary is fully permeating us, it all makes a difference. It's variable. So your ambient becomes something different, right? When you're out in the solar system, the average pressure of the solar system would sort of be your average ambient at that point. And then as you approach celestial objects, whether it be planets or moons or something that's going to hit us and then put us back in the Stone Age, whatever it is. It's like those have their own independent zones that are always going to be greater than that of the ambient because they're already in the ambient, right? So that's sort of an interesting way to think about it.
Yeah, I was looking at it like this. So we see a lot of systems out there, right? We see geometry coils. Say you make sacred geometry in a coil, and then you want to pick up energy from the inside of it. So you basically take a ferrite core, you wrap some wire or magnetic wire around it, and you put it in the center, and you're picking up a voltage field. The magnetic core, the ferrite, would give you more of a magnetism. You know what I mean? So it starts to balance out the system to give you usable energy, but the voltage would be skyrocketed high depending on how much compression in the coil that you have, right?
Uh-huh.
So
You
that
just
would
doubled on
be.
something though that just proved my last point. You see,
No, I did.
because
I did.
yeah, right, because you have the relationship. So you have this overall 0 point sort of a pressure zone, but then the sun is going to have its own pressure zone, right? And that's put now. Then you have this relationship with the sun, and here we are. There's an offset differential that then exists between our energy exchange rate, its energy exchange rate, and then their boundary interactions is what we are able to it manifests as our magnetosphere, okay, because it drops into magnetic components, and then as it blasts over us and stuff, then you have your plasma, you have all your plasma events that occur at those boundaries,
Yep.
super cool.
Okay, so let's go into the next one, and we'll talk about people's favorite thing is a donut. Okay. I don't really talk about them a whole lot because I don't believe in how they make it into making a plasma reactor or things like that. But let's just take it for what it is. You have this the shape, and basically in the center of it, you're looking for a 0 point. You're looking for a compressed field of pure electricity if you can get it. Okay. I just so everybody knows, and they probably already do, I don't believe that you can get to a 0 on the other side. You can get to 0.0000 something, but I don't think you can get to a 0 because of the way energy works. But because we can't put magical fairy dust to make a magnetic field appear, it doesn't work that way. But I digress. Let's just talk about the 0 point.
Well, hold on. Let's touch that real quick, though, okay? Because if you think of the 0 point axis, right? We already have 0 point axis. Okay, we're already in it. We're already doing it. It's already happening. It's already a thing. Every piece of electricity that you already use is created by manipulating the resistance. Okay, between, in my opinion, again, dimensions. Okay, so you reduce the resistance by reducing the pressure. Okay, and when you reduce that, then you increase the exchange rate, and the closer you get to the ambient pressure of the dimensional offset, okay, we would consider that superconductivity. Okay, and
Mm-hmm.
superconductivity is a full-on 0 point axis point, because at that point, any material that it's going to come into interaction with is going to receive its maximum exchange rate of the potential energy, and that's important, potential energy. Okay, because
Okay.
it needs to do something with it, and just because it's available, because of the state of potential, if there's no load on it, if there's no vectoring of that energy, then it's just what you would see is a time dilation effect, which then again, right, is directly then related to gravitation. So, I mean, but you wouldn't necessarily have a large amounts of energy unless if you start to pull that energy.
Well, okay. Let's look at it a different way. Okay. In every coil system that I mentioned, there's two sides of it. There's the one that you're looking for and the one that you're not looking for. And entropy tells you the reason why it's there. So if you deal with any kind of coil system in a non-core system, you're basically playing with the entropy in the air. So what you're doing is you're taking the hot and the cold that appears. Your 0 point is going to be fairly cold. It's a high voltage. You're looking at a magnetic field that builds out on the outside, which is going to give you heat. The entropy is going to pull it to the center, so you're going to get a rotation. Let's look at a atom and how it's built. The first thing you do is you're making basically electrical balls. You can put them in there. Okay, you can call them ions, you can call them electrons, you can call them whatever you want. It's just a ball of energy. So I don't mind how you define it. But what I say is, on the outside of that, in order to create that environment, you must automatically create a sheath zone, which would hold that in, which means you're making the magnetic part, even though it feels like the magnetic is not very strong, it is still enough to hold in the voltage part. And you cannot have one without the other. That's why.
Right.
Because as soon as you build the inside voltage, the outside appears, right? So they're automatically connected in that way in order to make that atom. As you compress it more, you get zones on the outside of more sheath zones, which creates that actual ball of electricity as your electron, right? So if we look at it in that way, they're linked. And you can't unlink them because one creates a pressure gradient that squeezes the other into the 0 point.
So, Aaron said something interesting, and I want to just kind of bring it into the conversation before it gets lost. He says, I think of carbon as the six, meaning in the Rodin spiral math, right? In the middle where the 0 point should be. Now, I agree with the carbon and the six, but I wanted to put it out there because I can't say I have a very good idea about this. Okay, um,
Okay.
it's the 0 point does not lie at the six. Okay, the 0 point lies at a point of 4.75, and if you've been following this for a while and watch us, and you might have heard me explain this before. I'm not going to go into the real deep of it, but the essence of it is that by virtue of the 1, 2, 1, 2, 4, 8, 7, 5, 1, okay, where it crosses, where it changes direction, okay, when it's going from 4 to 8 and from 5 to 1, okay, there's something happening there, okay, it's flipping its direction, right? And anytime you're flipping something's direction, you're inverting it, you're turning it inside out, there's going to come a point where it's neither inside or outside. It's somewhere in between, right? And where is that? Well, it's where they cross. And where they cross at 4.5, right? And it's, as I had said before, you activate your other ratios, your secondary process, the 3 and the 6 activating to hit the 9 pulsing down to this 4.5, the same mark, which is manifested of a 10 count. Okay. And when you bring the 10 count into the equation, okay, you now have a third process, your third vector, which is no longer the same ratio proportions because it's now stepping up from a 9 count to a 10 count. When you take all the pieces of the components together and find the median average of everything, okay, what you realize is that it's not 4.5. Once that third vector is manifest, it's 4.75, which is cool, okay, because what you end up doing is you look at where the 4.5 lies on that map, okay, and it does not sit at 4.5, it sits at 4.75. Okay, so that is the ultimate point of coalescence for all of the modes that are going on. So you have your 2 counter-rotational modes. The average of the 2 sides is the 4.5. The crossing point is where they cross is at 4.5.
Well,
You see what I mean? So,
yeah, but there's a golden angle in there somewhere that may be, I think it's 3.75, and you may need to look into that, because if that's true, then that's the angle in which the sunflower builds, and it builds out the energy based on the light. And they put it in all chapels around the world, all the churches, all the
yeah,
arches are built that way.
they have the stained glass and how they break up the panels in that same manner. I mean, listen, we have some sharp people in the chat. I'm not all knowing, so if you want to chime in as to the connections of the 4.75, on us, by all means. But I'm just saying, but where you map it out, what you realize is that all points cross right there, and that's where everything changes.
See, I think we're all on the same page there when it comes to that. There's a golden angle that they use, and it turns into the golden ratio, which would explain the math as well. Same thing that you're saying.
But so 4.75 and half, though, which is exactly what it is in the first place, is a half, right? Is approximate to 220, which Aaron is saying that the sunflower is related. So I mean, is it off a couple of marks? Yeah, okay, but I mean, it's close enough to say, is that a coincidence? I mean, maybe, probably not. If it was right.
Yeah, I think it's interesting. So I want to get back to the coil thing, because I was just trying to make a overall point. So we have 2 different designs, right? We have a flat geometry coil, we have a 3-dimensional Rodin coil, we have a donut. Okay, we can have a design like an orange, okay, where the energy comes down, and like Joe said before, it's one energy that comes down and goes, and then it sits in a point in the middle where it's almost equal, and then it turns the other way on the bottom. And that's true. That's the way it does work. And the Earth itself not a donut, it's more of a sphere shape, even though it's not all the way a sphere. But they all create the 0 point all the same, and they're trying to get to the same point. And it's this. When you get to the center point, it's like an atomic point. Okay, it is the atomic structure and how it's built. It's basically if you want to call them ions or something like that, it's pure energy in a ball that sits in almost a state of rest, is what it looks like to us as we observe it, because we can't see the motion in it. And they build out together. When they do that, they still put out the field out there, so you're still getting a magnetic value on the outside, which causes the compression to the inside, which is how gravity is formed itself. It's that simple understanding of that 0 point is the part that brings it into gravity. It also tells you how anti-gravity works, because in order to break gravity, you must make gravity. Therefore, it's the key to anti-gravity. When you understand that, you can now bring in the fact that it's radiation, not just magnetics, that is causing this. Okay? You're causing a radiation to go in there. Why? Because radiation structures air. It
Yeah.
does it all the time. And as soon as you understand that, then you understand field bubble research. If I wanted to create a bubble inside the gas environment that we live in, I need to know how to structure that gas. I need to structure that gas using radiation.
Yeah.
But I need to make sure it's a 0 point radiation, which is non-lethal, versus the compressed radiation we get in the wrong area. Okay?
So I want to touch this before
Go,
you go
go
further, right?
ahead.
So there's this situation where static potential does become radiant, okay? And the situation at hand is that whatever it's accumulating on has a certain capacitance, and you're going to reach a saturation of that, and then it's going to start saturating the air, okay? But now, as it expands into the air's capacitance is going to be much lower than the capacitance at which it's accumulating on, and it's going to go into a diffuse state as it builds out the area and the zones. Now, what ends up happening is that if the rate continues where it builds, okay, it's going to reach a threshold boundary, okay, where basically it's kind of gonna, I don't want to say collapse, it's not the best way to put it, but like it's gonna hit a boundary where there's a push down in sequence with the amount that it's coming out, okay, and that push down is actually gonna cause a compression that's actually gonna change the relationship of the charge value, okay, that occurs. So right, they're in an accumulation mode despite them being, let's just say, positive, okay, or negative, right? So they're all the same charge value. So they should repel, but they don't, right? But then when you compress it, they do, because now you've changed their relationship and their angular relationship, right? Through that compression. And then that change in the angular relationship is cause of an inertial repulsion, okay? And the way that it goes is outward, right? And it literally turns, and radiation in that case is scalar, okay? And it's
Mhm.
not manifest in any sort of way until a point of interaction. So
Well,
that's one way to think about it, I guess.
yeah. Well, when you compress things, it's like, okay, a Tesla coil may not be lethal to you right away. Okay, if you're just using it every once in a while. But when you get into taking a light bulb and you put it into it, and now you're putting a spark gap in there and you're compressing that energy inside of that bulb, you're creating an X-ray. You realize that they literally created radiation out of it by just doing that simple compression and giving it the ability to spark inside. But that's again what you're dealing with when you do things in a let's say a nuclear form inside the center there. You're creating that radiation boundary as you go, and it's going to ride right on top of your magnetic field every time.
Yeah, but you're
So
okay. So your rate, but it's also worth noting you get an X-ray, sure, but that's going to be depending on your rate. Again, because if the compression rate is contingent on the overcapacitance rate, where it's coming into the equation, right? And there's a direct relationship there. That means that the rate at which that occurs, okay, is therefore a frequency. And the frequency is deterministic of what type of ray it is. And if it's a high enough uh, frequency, it could well end up as a gamma ray.
yeah,
So, and that's important to know. And all it has to do with it is how fast is it creating this overcapacitance compared to the compression? The offset differential of that is deterministic of, again, it's like we talk about the same thing, it's a different context. Well, that's your beat frequency. That frequency, if it's high enough on that beat frequency, then all of a sudden, that is deterministic of what the ray is. That ray is totally scalar. It's not something they talk about. Okay, it is non-manifest in any meaningful way until its point of interaction where it's brought back in, and oftentimes it won't interact. It just flows right through, right? And that's what we know. It's like you have to be able to then collapse it at some kind of constructive or deconstructive interference point in order for it to be manifest.
Yeah. So I want to bring this up, Joe, in this way. So we do it from the RAV. We see the electricity form on the inside, right? And those little balls. There was another gentleman, and I can't remember his name right now, did it with magnets. And you see the magnets sitting a certain distance from each other, equalizing. You're not seeing the magnetic field in each one of them, but we know it's present because we know how magnets work. But then again, the balls of energy work the same way. So that is the de facto 0 point in there, which means if you want to harness the 0 point, you got to get to the center of our planet to do it. Center of a coil, and any kind of coil, as long as you understand entropy and how it works, and radiation on how to make it flow with the entropy in it. So it's more than being that simple. Okay. You also have to realize that the energy in the core of the Earth has a massive radiation going on inside there. That's what's going to take all of the stuff around it and make it hot. So normally everything's cold. So if you go over and you say, I got some nickel iron, right? It's going to make it hot. Why? Because the radiation does that. It takes an item that's naturally cold, and then it'll make it hot. But over time, what does it do? It melts it. So you're going to get a melted nickel iron core that works as basically a hollow shell around the 0 point itself. So when they say all the scans come back as a nickel iron core, well, we understand that because it builds a shell. We do the same thing when we build atoms. We build a shell around it. Whatever the environmental condition is for that atom, it builds the shell. That's what we see in our electron microscope. So
I love that you brought this up, man, because
okay,
I
go
just
ahead.
saw something recently. Okay, at a very mainstream source that I don't usually pay attention to, but I was like, oh, see, they're onto something that we kind of said before, but not really. And it was about the core of the Earth, and they were like, "For valid?" Like question mark? It's like, oh,
Finally
you're
getting it.
onto it. And once you realize, real quick, right? You have the idea that, all right, it's under a huge amount of compression, right? So usually when you compress something enough, it'll phase change into its most dense state. And since
They weld that way.
nickel is, whatever, so then you have a temperature situation where all that pressure is creating the temperature. So, that it ought to be at those sorts of temperatures, at least liquid, but probably even rising into some kind of almost a gaseous state at that point. And then you realize that it acts funny and it does funny things, and it doesn't really interact with the other layers the way that a solid normally would. So you have this thing that, for all intents and purposes, you would think of as a solid, but flows like a liquid. And guess what I have to say? And it acts like a gas.
Yeah.
It flows like a liquid, but it acts like a gas. What do we know that kind of like appears like a solid, but then flows like a liquid and acts like a gas?
Yeah.
What do we know? Plasma, man.
Yeah, plasma.
That's exactly what plasma. It's exactly what plasma is it not? It kind of looks like a solid, kind of even can condense like a solid, even appear
Acts
to
like
be
a
a
gas.
solid, flows like a liquid, and acts like a gas.
Mm-hmm.
Yeah, and you realize that, okay, what happens if you have all that pressure? What happens if you put all that plasma under pressure like that? Well, it would probably resemble exactly like what you're saying. So you have like and when you realize that the next layer above it, it's only like kind of sludgy liquid, they say. I mean, you know what I mean? Well, you're looking at the layers of it building out. There, if it's that hot, there's no way that it wouldn't basically melt the earth. You
Right,
see?
right.
But it
But
doesn't. You see what it doesn't.
here's why. Because in every single one of those sheath zones, you have levels of high energy, levels of low energy, until
Mhm.
they reach another level of high energy, right? So it allows for that stuff to become solid in there and then go back to liquid. It may be in a
Yeah.
crystal state, more like it in the center because of the pressures,
It's
but
exactly right. It's like a structured plasma crystal,
yeah,
quasi crystal state, and it's in a state of compression. And if you well know, like when you look at the RAV, right, it doesn't give off the temperature to the environment like that. It
no,
doesn't give off the light like that. You know, it doesn't light the environment, although it's exceedingly bright. And these are the things that we do kind of see and observe and know about the core. And it's the whole reason that it wouldn't melt every single layer up to the crust to the point where we're on a ball of lava. You know?
yeah, because we
Right.
would just die. Yeah,
Hmm.
yeah. So I want to also say this. We're building this thing out, and it makes sense because it all shows it when you start dealing with plasma and you start dealing with energy levels. But it goes also to the magnetism. Why do magnets not float in the environment you're in around it? Because the environment you're around where you are acts like a sheath zone. It doesn't act like a magnetic zone. See, there's a big difference in how you see a magnet. And I gotta say this, and God help me, man, because it drives me absolutely up the wall. They say there's more powerful energy in a magnet than there is in gravity. Okay. And I'm just going to tell you it's asinine to think that way. And let me tell you why. One's on a planetary scale, and the other one won't reach 5 feet. Okay. You can rotate it all day. You're not getting past 5 feet. That's your magnet. The other one's a planetary scale. So when you start thinking about that, go get your shovel and start digging to the other side of the earth. Tell me when you get there and tell me how you got crushed in the center, and you tell me how strong it is. Okay? Because it's based on locality. You're at the end of a system that's going out to the space, is what you're at. So it feels weak. Okay? Because it's a sheath zone, it's not magnetics in the way that you think of it in a magnet, right? Why? Because the earth itself uses all the minerals in the earth. It doesn't just use the what is it? The neodymium stuff, right? It doesn't just use that. It's using all of it. It's using the cobalt. It's
I
using
mean,
every
it
single
has
thing that
not
can
right.
create
I
a
mean,
magnetic
in
field.
my opinion, that the material makeup of the Earth has very little to do with its
Yeah, but it's,
magnetism in general. I mean, it just manifests as a result of tertiary processes. But I mean, I think the better way to look at it is that you know, the- when you're looking at the geometry of magnetic fields and magnetic interactions, you have outer zones and inner zones, and again, they're dimensionally higher dimensional. In the processes, you get to right now we're in the inner zones of the magnetic field. We're not in an outer field, so we don't experience the magnetism of it. Whereas the further you go toward the center of the Earth, you're further into the center geometries. So when you come down the central toroidal axis points of a magnetic field, there comes a point where your relationship to your own polarity changes, right? And there'd be a lock zone because you're neither north nor south that goes into a state of diffusion. We're already in that state of diffusion. Mm, the further away you get, the more from the main source toward the outside of a magnetic field, the more the polarity of it all has an effect.
but hold on. But that's the point. You see, if it was truly weak, okay, just understand this. We wouldn't have the bubble around the outside of the earth. It wouldn't exist. It has to be a strong force that we're not recognizing as a strong force, okay, in order to create enough energy to put that bubble around us.
Mhm.
See, that's the problem with equating magnets to it because you're not seeing the full picture. You're not seeing what's going on. You're thinking of strength in the way of brute force in a magnet, and that's incorrect. You have to look at it as a sheath zone on the outside, which has its own force, which has its own compression, and it's not normally recognized. That's why you can't just go out and throw magnets into the atmosphere or something, because they don't work the same way. Okay? You may throw something very small, very minute amount, right? But then again, friction does that. You do that in order to make static electricity to shock your brother or sister down the hall. You know, a lot of things interact with the environment to give you that tiny bit. It's like saying this: if I want to reduce the weight on the scale, I can use AC, I can use DC, I can put a 220 on it, I can put as many amps as I can on it, or as many volts as I can on it. All of them will give you a movement on the scale. Okay? It's flat out. Why? Because you're interacting with the environment to do it, but you're not interacting enough with it. You're not speaking its language.
You're coupling. There's energy coupling to the matter, and you're changing the relationship of the energy densities with that of the ambient environment.
But you're only coupling it, what, 0.0001%?
I mean, right, but I mean the movement on the scale in that circumstance without multi-mode vectoring is pretty limited in the first place.
Well, that's why you get into energy coupling, because you're basically using the environment as the energy. You see, this is why 0 point's so special. Because take the center of a Tesla coil, why it's different and why they can't figure it out in physics. Okay? Because you're literally taking the air that's in your room. You're compressing that air together. So what you're doing is you're taking that 0 point energy that is non-pure, and you're trying to purify it, is what you're trying to do. And as you do that and you get closer to purification, it means that it's now going to go around and create the same environmental condition as the 0 point again, which means it's going to create that structure in the air, which gives you your coupling factor. Now you can fill the bubble with energy. You see what I'm saying? You have to think about why it's doing it. Now, a 360-degree sphere does the same thing. It compresses it the same way, and it'll give that same gradient. That's what's important to understand here. You're purifying everything out of it in order to get back to the original state of the energy of the 0 point that the Earth gave you. Okay? You're not using something that's non-reactive to it. You're using something that's 100% reactive to it because it's built right out of it.
Okay, so there's this situation, and it's kind of interesting to think, okay, because you have a situation where if you take a current vector, okay, and you introduce the current vector into the earth, the ground, okay, and you create a magnetic field, and then you have a load on the other side, it'll pump and pull a greater amount of energy from the ground, okay, it's proven out, what happens. Go home, and if you are competent, go fuck with your house wires and realize why the electric company doesn't want you to do anything like that, with your service line. Okay, and why your ground wire is just railroaded into the ground and hooked. Anyway, I digress. And you realize real quick that your earth energy is in a potential state, it's in a static state, okay? And you need to be able to bring in the excitation, the energy vectoring to cause it, right, in order to then bring it into, from a potential state to, increase your energy. And then you look at when, Sean and Jarvis were playing with the electrodes, and I remember Jarvis one time he was talking about an electrode and why, yeah, it might be kind of a dangerous proposition to do something like put one on an airplane. Because putting a static potential in motion, right, up there, where it's in a more current state, right, is the inverse equation of what I just described. So now you're literally moving a static state in a current potential, and then now all of a sudden you could have a discharge situation from something that's otherwise inanimate. So very cool. And he said that the faster you go, the more energy it's creating because you're putting it into motion.
Right.
So it's the same. You have one that's a well in the ground and one that's a well in the piece of plastic. One has to physically move, one has to virtually move, and you're just literally taking the equation and flipping it upside down. So,
Hmm.
yeah.
I'll tell you what that grounding does. It kills the telluric current that goes on inside the ground itself. So if you understand lightning, lightning gets to the ground, creates a telluric current that will actually make your plants and stuff grow really well. What kills it? Grounding, because you're taking a different frequency and you're throwing it right into the ground, and you're ruining the frequency that's in the ground. It disturbs it. It's starting to convert an energy to the power source that you're constantly putting in there. Therefore, it ruins the telluric current, which means that we have to come up with different avenues on how to build plants and stuff. So they come out with a bunch of fertilizer and garbage like that, instead of using the old school method of just running wires in your garden in order to create enough magnetic field in there, because the earth is a battery in order to grow your plants better. They ruined it by grounding everything out. And
By the way, this is what Rav does, just in case anybody was wondering
yeah,
how that ties into it. This is what Rav does.
so hold on, I just want to finish this one point.
Yeah, yeah.
It's not the grounding from the rods up in the top of the towers is what I'm talking about. That one is the telluric current. What I'm actually talking about is from the power source from the lines that come in. That's the different one. That's the one that's ruining it. Okay, we're not talking about grounding rods here.
No, definitely not. But what you were just saying, and then what I was just saying before about just note that this is what the Rav is doing, right? You're by putting the cathode in a diffuse state, and then concentrating the other, it's getting there's a pull and an exchange that's occurring between the two. But
Mm-hmm.
you're taking the cathode, and because you're putting it into this diffuse state, it's really just adding massive potential to the well in which it's in contact with, whether that's directly a substrate or whether it's through gas and water. The whole point is that it's actually not putting anything all too much out, but potential. And it's the limited interaction that they're able to have that is the creation of the high density. That's gonna create the um, the two magnetic components that are separate. Okay, but then they come together and their center bounds work together, right? So what you end up with is, you know, two separate magnetic fields that are inverse one another with their center junctions, coming into a state of union, you know.
Yeah.
But just know that that's what's happening. It's static. It's ground. It's the cathode and the ground state in that case.
So I want to tell you guys a funny story. Bernie just went back to Canada, but before he left, we did an experiment, and we had our battery that we made. Right, it's the orange battery, and I wanted to show him the difference between static electricity and what the 0 point energy would be. Okay, so and I know them to be different. I know everybody else doesn't see it that way, but I'm telling you they're different. So we put this Tesla coil, I put the wire down the center, and then I hooked it to one side of the battery. And we started to dissolve the crystal that's inside of it, which is there because the sugar was building on it, right? On the plates when we had it charged on the 2 amp charge overnight. So we started to break the crystals down, but then the tray that it was sitting on, because the thing was leaking and boiling over a little bit, because there was gases coming out of it. So what would happen is the plate itself became extremely radiant, right? The radiant energy was just pouring out of this battery, right? Because there's nothing to hold it back when you get to this type of a field. The 0 point, you can't hold that thing back. There's very few minerals that could do it besides like mineral oil. So Bernie goes over, man, and he didn't know any better, and I forgot to tell him, okay? And he went over and touched the tray thinking it'd be all right. Just burned the living daylights out of him, man. He's like, what the? You know what I mean? So, yeah, and then I turned everything off, right? And I go touch the tray again. And he touched it, ice cold. So just understand that when you get to static electricity, had he touched it and had it been static, his hair would have stood up, right? Would have had a cool picture, funny, everything, right? Didn't happen. What happened? There's a high amount of radiation in it, and that radiation itself is what got that aluminum super hot. You know what I mean? For him to get zapped on, but then was cold. It was completely cold as soon as it turned off.
Okay, well, I mean, this is mincing words because we're in agreement about, but to call it radiation until it's radiation is like, I think that's where it kind of gets a little funky. It's like the plate is stored potential at that point, like, and it's going to reach a state of, and we talked about this before the stream. It's going to reach a state of saturation of capacitance. And then it'll start to, act kind of like a gas a little bit until something happens. But then what happens when you touch it? Well, I mean, when you touch it, you're introducing a much greater amount of capacitance that is not in saturation, and you've just given it a load to move to, meaning that you've now vectored the unvectored energy. Okay, and that's going to cause an RF burn. Now, there's no, there's no, there's no temperature of the material itself difference, because the holding of the capacitance of potential it's not in a state of excitation, right? So because it's not an excitation, we know it's the excitation that causes the heat.
But that's the point. It stays 0 point energy, tries to stay in an equilibrium state on its own until something interacts with it.
Mm-hmm. Now,
that's the point.
Remember what I said about what the point of the 0 point is to return matter to an upper dimensional state. Okay. And what I had always postulated was that as it returns matter back to the upper dimensional state, what we see as conservation, okay, is actually the signature of the departure of matter to that state, upper dimensional state, which is heat. So,
well, hold on.
There you go. You touch the 0 point, you get burned, because the rest of you is here to feel it.
Joe, it could be light in this case. So let me just say it this way, because remember, light's a reflection, right? So what we're doing is we're introducing a big charge to it and getting a reflection off of the surface. Therefore, that's what's causing it to build up in there. It's a higher state of energy inside of the object that has no place to go until you touch it. You know what I mean? So it could very well be a light as well. I'm not saying you're wrong. I'm just giving another thought. What's up, Richard?
Hey, Richard. What's going on,
brother?
Yeah, John's saying, anybody know the impedance of free space and how something is supposed to be nothing? How something that is supposed to be nothing has impedance? Well, the interesting thing about the second part of the question, okay, is something that I said earlier, which has to do with these gradient zones, these bubbles of etheric pressure that have to do with the etheric pressure, the exchange rate, and therefore the impedance, right? So because you're in the solar system, and when you're, in between planets and so on and so forth, we're in space. Okay, yeah, I mean, you're in space, but you're not in free space like that. It's you're still within the relationship of this greater ambient pressure that is shared in a diffuse state around everything that's within it, right? It's not
because the sun makes its own
outside of
bubble.
all these zones that you would then more truly be in, but then who even knows? If that exists at all in this dimension, which is a whole nother point, we don't need to open up that can of worms. That's way too esoteric conversation.
I don't know why it's so hard, Joe. The cosmos has a bubble around the whole thing.
Yeah.
So no matter where you're at, there's energy.
The first part of the question, though, is that it's variable, right? So that's the point. It's variable because of the fact that it is encompassing of a certain area, right? And it's in a diffuse state as it probably moves toward the most energetic object, right? The thing with the highest energy exchange in that area, is what establishes the relationship, and for us, it's the sun, right? So,
Well, everything has impedance because everything accumulates, and everything that accumulates will cause it to have impedance. There's no such thing as no impedance. It still has a certain level of it.
it does,
You may deflect it, you may do other things with it, but it still has it. You know what I mean?
right, because you're here and not there. and
Yeah.
that, and that's the point. Now, I mean, also one thing that's weird too is, and you just got to get like this, picture the solar system, what it's actually doing in your head. It's like you think back to school when you have the sun in the center, and then all these little wires sticking out with all these little ball planets so that you can spin around the sun. And I mean, that's just weird. That's just not how it goes. You see, like you have it's like it's more like NASCAR, than anything. It's like you have this one guy, and it's the sun, and he's in the front of the pack the whole entire time. And everybody else is weaving in and out, chasing the damn thing the whole time. So nothing ever crosses the front of the sun, is the point. Nothing ever crosses over the front of the sun. That's not how the orbits work. So, the distance is weird because we perceive the distance because we like to picture in the model that you're taught at the most basic levels that it's almost like if the sun were sitting still and everything is just going around it. But the sun's doing something too. It's going forward. We're not. It changes the dynamic, puts it on its side. Sun's here and everything else is orbiting it, but like this. And at different levels back. And that's one of the parts that they don't talk about. Because the way that you would have it think is like the planets are all aligned like this all the time or something. But in fact, it's like, no, you have your guy in front, and yeah, there's might be a little alignment going on, but most of the time it's like this, that, and the further back you go from it, not the further away from. It's weird,
Well,
it's like completely wrong.
no, it makes perfect sense if you understand how energy works. So if you create a sun in the middle of summer, right? What happens is it sets a condition on the outside of the solar system itself. It makes a bubble, okay? And in that bubble, you have sheath zones. For every sheath zone, it's going to show up as a higher state of energy and make a photon out of it as soon as you create too much energy into the sun, right? So then when you look at where the planets are, they ride the sheath zone, okay? Either on one side or the other or in the middle, depending on how much energy the planet's getting, which means it has a direct relationship with the sun. So as the sun moves back and forth left to right, that means that those zones go with it, which means our planets go with it, which means they're all entangled to the same thing. They're all getting their energy, not so much from the sun bursting out big things of energy from it, but from those zones itself. It's a natural understanding of how 360-degree physics works when you're dealing with plasma. It builds out in, 360 degrees. So you get spherical plasma all the way around it. And it does work like scalar at that point. So, I mean, it's not hard to understand the boundary zones. As soon as the sun moves, the whole thing moves. You know why you don't
Yeah.
feel you don't feel the whole thing going through the what do they call that? The big thing. You don't feel the whole sun moving around, out there. Why? Because as soon as you created that bubble, it feels it on the outside of the bubble. It doesn't feel it on the inside. On the inside, it's like purified, so it doesn't feel like it's going anywhere.
Yep.
But really, we're hurtling through space, man, like billions of miles an hour, and we won't feel a darn thing. But it's the same thing that happens on our planet.
Right, right.
We're spinning like crazy,
We
but
have
we can't feel it.
we have a partial non-locality to the sun, is what it
Yeah.
boils down to via our magnetosphere. It's why we don't get roasted and toasted, as it stands. And if you think about like the whole bubble situation and why the ambient of the solar system, for instance, right, isn't zero. All you really have to think about is like if you had a sugar spoon or something, right, and you had a 5 gallon bucket of water, right. If you were to stir the bucket of water with the spoon, okay, how many molecules of water are actually in direct relationship with the spoon? Very, very few. However, every molecule in the bucket of water, okay, is going to be affected by the stir of the spoon.
Hmm.
Okay. And therefore, there is not a state of rest. And the further away from that state of rest you get, that's going to be cause of excitation, and the excitation in general is going to lead to certain degrees of transient energy manifestation, in which turn becomes felt resistance or perceived resistance. And it has a lot to do with time dilation as well, because we perceive it as resistance because it's only partially manifest. Well, it's in transient state, whereas the most of the energy is actually non-manifest, in my opinion, again, upper dimensional state. So I don't know, it's because it's a low exchange rate, right? The exchange rate is closer to an ambient zero. Again, these boundaries are defined by the Planck scale, right? So the Planck
I,
scale has two sides.
I think, Joe, if we could actually see the energy going on in the solar system, there would be no such thing as understanding dark matter. The game would be over. And it goes like this, okay? We don't see UV, but it's there, right? There's other spectrums of light we don't see either. You see, this is the problem here. It's always full of energy, yet you don't know it's there because you can't physically see it. But when you start interacting in its own language to understand it, it's right there. Do you need a whole bunch of energy when you go out to space? Not if you understand what it is that you're dealing with. Then it becomes, can I get to a sheath zone? Can I make it, propel from that? It becomes that easy. Okay, but you got to understand that. And I don't think a lot of people do. Right now, as you go outside, there's UV everywhere. Do you see it? No, you just see light. You're not understanding what's going on around you. There's energy everywhere, all around you. You're not interacting with it in the same way. So if you say dimensional energy, that's what I think of. It's just in a different spectrum we can't see. Now, can your dog pick it up? Yeah, he won't go near a hole in the earth if it has a bunch of energy coming out of it or sound. He won't go anywhere near it. He'll pick up on it right before you do because he hears differently and he sees differently. Okay? Those are the things that are going on around us we're not perceiving. If I tell you we're in gas, you can't see it. You don't know that, right? But then people say, well, it doesn't build out in layers. Well, that's because you have wind. That's why it mixes, because you have wind. It's that simple. Once you get rid of the wind, what happens? It layers. So it's very simple. It's very easy to figure out that there's layers going on already. I think a lot of this stuff, Joe, is they don't really realize anything about the environment that they're in. They think it's just wide open, jolly, gee, I don't know what it is, but that's not the case. It's structured 100%. It's mathematical precision and geometry. It cannot be reached or seen if you do algebraic equations. I think I come to that conclusion on it, Joe. They can't see it because they don't understand it. They don't. Yeah, they just don't
Right.
understand the difference.
They're looking. They're more interested in dissecting the parts of the parts of the parts of the parts. But you at a certain point you fail to realize that you've broken it down as much as it ever has to be, and now you're just cutting the same thing into lesser pieces. But those pieces are just you know subject to how you cut them. That tends to be what I think that is going on. They really don't understand. They're not looking for the mechanism. If they really realize that the geometry is the key, okay, and they gave credence to extra spatial dimension, and then they gave looked and started connecting the dots between geometry, the Planck scale, and then energy, and realizing that the high and low excitation points, okay, all actually amount to the same thing, okay, just in a different way, right? When you kill the temperature of something almost entirely near absolute zero, well, physics starts to break and matter does too. And that's when you start to see weird stuff like matter going through matter. But I thought that when you froze something, it's supposed to go into its hardest, slowest state, right? Its most dense state at that point for most types of matter. Ironically, not water. Anyway, never mind. Okay.
Go on.
Right. And all of a sudden the physics is breaking. It's because you have an energy return to the higher and lower dimensions, but through the fact that it's reaching a still because it's falling off the Planck scale. All right. And the boundaries no longer exist because the resistance is so close to ambient of the pressure, the etheric pressure, that literally the energy is just going straight back where it came from and it's okay. Right. Now, on the other hand, that where there's heat, there's high resistance. That's hysteresis is heat, and hysteresis is exactly where it's at, which is high impedance, high resistance. Okay. And that's because of the returning to a high excitation state. Okay. When you bring something into its highest, uh, excitation states, what does the matter do? The matter starts to break down. Okay. And it goes into heat and it turns into plasma. And that plasma is the bridge of the gap on the high frequency side of things between dimensions. So there's a low energy uh, dimensional exchange and a high energy dimensional exchange that occurs, and it's defined by the very things that we talk about. It's plasma and basically sucking the energy from something. So now think about this: when you are creating plasma of something, okay, and you're creating all this heat, all right, you're creating a low energy state, right? So you have it then dropping off of both by creating high energy plasma, high density plasma. You are taking matter from both sides of the scale and dumping it off the Planck scale on both sides, right? That's what you're doing. That's why on snowflakes in some configurations, if there's no electrons reintroduced into that equation, nothing locks into place, no relationship ceases to exist as soon as the power's up, because the only excitation that it has left is that of the system in which broke it apart in the first place, which led to it then trying to order itself in hopes that it may regain electrons to be able to join back up. As soon as you kill that power and it no longer has it ceases to exist. Why? Well, that's why, because you created the low energy state and it was right there.
Yeah, well, sometimes the energy stays in it. And I've had it happen to me. We did it on the battery we just built. The energy stayed in it. And there's a reason why I did it, because it's messing with the environment. It's creating a capacitance inside the environment itself. So I did it with my coils on put coils in a geometric configuration on one side, and I have a driving pillar. Then you can run the driving pillar down to nothing, like 3 volts, when the trigger voltage of the MOSFET itself is 5 volts. How does that work? Well, it's creating capacitance in the air between them. The energy's transferred already, so that it picks up enough to fill up the capacitors going back into it. And that's true with everything in the environment. They create that condition. So, yeah, the energy is a little bit different than what you think it is, and it's because people say things like, okay, the tunnel vision. If I say energy, I'm talking about heat. I'm talking about cold. I'm talking about, electricity. I'm talking about energy, right? Everything. I'm not talking about electricity. If I wanted to say electricity, I'd say electricity. But people have tunnel vision. They can't understand it. Okay? They go, oh, no, nanu, it's not there. It's not there. Yeah, but it is. But as soon as you can learn how to transfer between the energies, you now have coupled capacitance. You see, that's the point. If you want to keep something held into something, you must create that. That means that you're pulling that environmental energy in and holding it, right, in a capacitance field, which means it's coupled, which means it'll stay there longer after you turn it off. Okay? Failing to realize that energy is everywhere and you can convert that energy is a failure of understanding what you're doing, because most people who get into anti-gravity think that all you're doing is pumping energy into something and somehow miraculously it's going to go up in the sky. And that's never going to happen. Okay? Now, and I'll show you other experiments that think that's going to happen, right? They go over there and they take a DC flyback and they put this aluminum foil down. They put aluminum foil right here, and then they get this little thing, looks like a teardrop, like a little ghost, and they put it in the center, and it stays there, right? Do you think that's anti-gravity? It's levitation, but it's not anti-gravity. So what's the misunderstanding? And it goes right back to the fundamentals of anti-gravity. Your high point in the atmosphere is way too high, so your anode is way too far away from your cathode. You'll never reach the point in the center, and you can't put enough energy in your craft without frying you to equalize between the 2 points. It's an impossibility. It'll never happen. That's why you cannot just put energy in something and have it lift. You must work with the environment to do it. And if you fail to do that, you fail the whole experiment. It's a learning process. You see, that's why I know when people say, oh, I need this special element to make it so that I can have zero resistance. Buddy, I can give you all the zero resistance you want, okay? I can give you a supercapacitor. You know why I know you're going to fail? Because you still have to have magnets underneath it in order for it to sit up that high and run. You did not break gravity. It still runs on a magnetic track. You see, for all the understanding they have of a superconductor, they still haven't realized this. Even if it has almost no impedance, or zero impedance if you want to even say it that way and argue the point, you still run it on a magnetic track. You do not have the ability to decouple from the environment and go anywhere. You don't have anti-gravity with it.
That's
So
not
you can
so with
use all the nano coating you
superconductors.
want. It won't help.
So with superconductors, it's interesting because if you were to have a room temperature superconductor, what you're doing is you're actually taking the material and putting it into an etherically ambient state for the most part. Okay, but from the outside perspective, it see, but it experiences everything as normal. Okay, but from the outside perspective, everything seems instant because you're literally you're using a wormhole at that point, is what it is. You're using a wormhole, okay, that is, yeah, because look, the time dilation is different, okay? It was doing that all along, but now you can see it and use it in your reality because you have both sides of the wormhole contained because it works off of a separate locality from that of the outer environment. So you are not in that material. So you are not part of that time dilation field, but it is still here in phase. Okay. And when you use it, you experience it for what it really is at that point because you leveled out the ambient, the etheric pressure. You see, that's what superconductivity is. That's what's crazy about it is that literally it's saying, okay, we have this material that is in a state that we are not in, but we could use it in the state that it's in to, for our needs, which is to be able to have instant transmission of something or lossless transmission of something, or to be able to pull more energy out.
The
You
only
see,
thing, the only thing that superconductor did, hold on, I gotta stop you because the only thing that it did was it made the field bigger and stronger. Okay, so just understand what I'm saying. It still rides on a magnetic track. It it only made it stronger, so it'll stay locked into that magnetic track. In no way has it ever shown the ability to go through a wormhole or to move up in the air. It stays on the track at the exact same height as much as you want to push it, as much nitrogen as you can throw in there to cool it. It goes at the exact same height on the exact same track at the exact same distance in the exact same parameter every time. Does not give you anti-gravity.
no, it doesn't, and it wouldn't because you're not. Yeah, it's not necessarily how it would work. I don't know. Anyway, digress. But what I was saying is like it's actually what they do for these quantum computers. They super chill at superconductivity. That creates an entanglement state, okay, because it has a shared energetic source, it has an open energy source, and it's constantly flipping back and forth. Usually, that entangled pair would either be implausibly far away, but you basically allowed by opening up a dimensional portal, you've allowed for that to be here and visible and then you have access to it to see it because you're looking in a window into a 4D reflection. So then you're able to see and measure exactly what those quantum states are by superconductivity. They don't put it that way because it sounds high weird, doesn't it? And they don't like to talk about dimensions, and that's not how their model works, because they have yet to link GR to the theory or quantum field.
Well, they're still using copper, so they don't even understand supercomputing yet. They haven't gotten to the graphene level where you actually use the energy faster, which it has memory in it itself, which eliminates a lot of systems, which they don't do. It's like a Flintstone car compared to what you could have, right? We like the Jetsons, but we're in the Flintstones. They're not there yet.
Yeah. Well, I mean, all this shit is not all too different than the center of the crystal thing that I keep on bringing up, man. Because it comes down to the center of the crystal. It's the same exact concept, and if you understand that, then you understand it. There is a point where the information from any one given point is going straight through the crystal, right side up, and then at the same exact spot as every other point around this crystal, it's going to flip and invert and then project upside down. And it's at this point where it's neither right side up or upside down, that there's a hole that exists there. I've seen the hole. I've taken pictures of the hole. We showed it last week. There's a hole that exists, a real hole, okay, in which it's upside down and right side up inside the hole. And one leads right to the other. That's exactly what this is, time and time again. It's the pendulum that's swung up and hasn't started to swing down yet. It's the image that's traveling through and then about to cross itself so it inverts, but it hasn't inverted yet, but it has. You see, there's a point where both those things have happened.
Mm-hmm.
So where they cross, it falls off the Planck scale. And all this data just dumps and pours into there, and then in real time comes right back out.
Well, I think that's a theory of how it works. I don't think that they actually got it going that fast yet.
I don't know. When you bring things near absolute zero, man,
but they're having
to use copper.
Hold on. But that's not the case, because the number one issue with quantum computing is how hot it gets. They're having trouble cooling it. So if you're having trouble cooling it, guess what? You got hysteresis. You got hysteresis, you don't have superconductivity in it. So therefore, those states don't exist if you're having trouble cooling it. You have to get it below that point.
Okay. All right. You're not going to love me for this because I disagree with you.
Go ahead.
The reason you need to cool it is because the colder you make it, the hotter it gets. Get it? Remember what I said before? When you get closer to the ambient states, it doesn't fall off of one side of Planck scale, it falls off of both. So the colder you make it, the hotter it gets. The colder you make it, the hotter it gets. It has nothing fucking to do with whatever you're thinking. It has nothing to do with hysteresis in that sense of the thing. It has to do with the dematerialization. But the thing is that once you get it to fall off both sides, okay, there's containment. Okay, just like the RAV, containment. So you have, the super hot state, but then separate of that, you have the super cold state. Super hot state, super cold state. Well, it's not about cooling the super hot state. It's about containing the super hot state. And having the super cold state to have the low resistance, to have the super hot state and compression, so you have all the resistance. Because those are the two things that are joined. Those are the entangled bits. Because they're born of the same. And when you push one further off one side, the other side goes further to the other. And that's what you see in the light spectrum in the RAV too. It's like I said, it starts in the middle. You've seen the green plasma. We've seen the blue, the yellows. It starts in the middle in the visible spectrum, and then it pushes outward equally to the sides, and then falls off the spectrum.
So you're saying there's an energy exchange inside of it, like the RAV has?
Yeah, okay. Exactly. And then there's the cold side of it too. and they have to induce the cold side because in our case, right, the cold side's virtually there, and you could see remnants of it, but you don't have it fully there, right? So you need to introduce the superconductivity through the low thermal exchange of that. I don't like it. And by the way, I've never heard anybody ever say this about a quantum computer. Okay. I don't know that this is even the way that they understand it. And you know what? I'll put it out there and be humble about it. I could be very wrong, but I'm pretty sure that this is the same, that is the same, and this is the same, and that is the same. And when you start to look at it that way, you start to realize, yeah, the colder you make it, the hotter it gets. The colder you make it, the hotter it gets. It's not about trying to cool the hot. It's about trying to contain it.
Well, unless they're not getting their frequencies right. So that's where most of the problems come up and the swing comes. If you get the frequency right, then it flows naturally and it doesn't have any impedance almost. You know what I mean? That's the key to it. And it could be something as simple as that they missed. I know, like, for instance, a lot of electrical systems fail when they fail to realize that. And they just put in components because they think the values work, and they don't put it on based on the level of heat or anything else that goes on in each one of them. And you get random frequencies because for some god awful reason, some moron said once that DC doesn't have frequency, yet they write a whole equation on it that says that it does. And because they did that, now every Tom, Dick, and Harry goes over and screws up their DC system and creates excess heat because they don't understand frequency balance. But then you put a RAV on that same system, heat goes away. Why? Because it's balancing the system in free flow of energy. You know what I mean? It's making everything resonant, kind of like your Slayer Exciter does. You know what I mean? It contacts everything in this vicinity of it, and it tries to resonate with it, and it tries to bring all the values to the same level.
But the thing is that, and see, I mean, that's a great example. But if the properties of your material aren't, and this is where the impedance comes in again, you'll see why. If the values of your material aren't, in tune, okay, with the frequency that you're forcing excitation into, okay, you end up breaking it. You see, so you end up dematerializing it, and that then would show us a heat signature, but it's actually dematerialization.
Well, it's like when you blew up your crystal.
Yeah.
It got to the highest state of energy, and then it couldn't handle it anymore.
Exactly right. It was ripping the lattice structure bit by bit apart, and then turning that into, immediately into really high excitation material, plasma, along with it. At that point, it was returning it back, but it was forcing it into that resonance, but the material can never sustain. So and that's the opposite of, being able to capture and compress. So you want to, if you want to be able to capture and compress like the RAV does. And the only way that you could do that is through self-structuring, right? So you need to let these things find their natural points where they're able to function and be comfortable. But that's also why not every RAV configuration works. You start bringing in elements that can't fall into a resonant state that is going to be compliant with the beat frequencies of everything else, and so on and so forth. If you screw one thing up, you just cut the belt to all the other pulleys. So now the RAV doesn't form because you don't have the synchronicity of the system.
Well, see that the Slayer Exciter does the same thing as well because it goes into the power source and tries to resonate with it. When it can't, it throws back energy into the system and blows the whole thing up. So yeah, I mean, I understand when you're too far apart on the frequencies. You know what I mean? You have that problem for sure.
I mean, for what it's worth, if your molecule size and the complexity of the material or the gas or whatever it is, is in a diffuse state like that, where it's loose and able to move, forcing something into resonance isn't all that crazy. But then what does that mean for what it is in the first place? Is it losing electrons and protons? and becoming something else. You know, see, it's interesting when you start to think about it.
It's definitely stripping not electrons, but what the hell? Sorry, ions from material. So if you wanted to take a nuclear warhead, the first thing you need to do is take the metal around it, and you need to remove all the ions from it, because ions give rise to the potential state of energy. So you have to strip it out in order for it not to accidentally go off. And that's exactly what they do. And it's the same thing that happens in the lab. We always say that they're electrons. It's not electrons so much. It's the ions that are being placed on the center. And there was stripping it out. And the electricity flows over the outside and goes back through the cathode. And we know this because it bounces it back continuously. And the only loss is the loss of the material itself.
So, I mean, not for anything, an A bomb's a great example of 0 point energy. Excellent example for what it's worth. Fission in general, right?
Oh, well, you can see it.
When you
can
bring
see it.
when you bring something into critical mass, and all the material splits and goes away, right? That's what it comes down to. You've created a energy exchange rate at that point with the high potential of the material that's radioactive, right? Throwing off a whole bunch of stuff. They say that those collisions, accelerate, right? And that happens to be true. Why do they accelerate? Because the exchange rate has changed. Therefore, the time dilation has changed. Therefore, the ambient pressure has changed. And once the ambient pressure approaches what we would consider critical mass, which would be, ambient with the etheric, all of a sudden you have full-blown dematerialization and energy release through the heat signature, because it's returning dimensionally back. Probably why after we detonated a nuke, interdimensional, entities and stuff were like, oh boy. Wait a second. They opened up a hole to us and we saw them and they were all, you know what I mean? And it's just like, we don't even know what that shit does. But it all makes sense.
Yeah, I think people don't understand the 0 point the way that they should. I'll just go back to this so we can kind of round back to it. We can create it in coil setups if we want to, if you know what you're looking for. You got to get a lot of this gibberish out of your head that they keep telling you, okay? They called balls of energy 5 different things, as far as I know, maybe even 7, okay? But they're still just balls of energy. If you get all that gibberish out of your head and how they keep trying to malign you by arguing about that stupid point, and you get on to the real understanding, energy has been created the same exact way, same power source the entire time. All you did was manipulate the environmental condition to compress it, flatten it, make it into a geometrical structure. That's your change. That's what brings out the conditions you're not seeing. That's what brings out your radiation. That's what brings out your entropy. That's what brings out all the other processes that you think are emergent, but have been there the entire time. They're just not present when you're doing it. It's like a magnetic field. It's been there the entire time. It's not fairy dust that make it appear. It's always been there, but the amount of it's so low because there's something else taking its place. It could be that the radiation's so high that the magnetic field feels so low. And in comparison, it's all just a bunch of bars on a graph that actually tell you what's going on. I think people fail to see that. The energy did not change from the source. You compartmentalized it in different ways. It's why experiments fail. You make a linear experiment, okay? If I take a saw blade and I take a base of iron, right? And I put energy between them. Linear experiment, flat experiment. Why does that fail to a 360-degree experiment? Because you didn't understand the environmental condition that created the pressure within it. Therefore, you get 0 pressure almost in your linear experiment, but as soon as you change the geometry to 360 degrees, you get a massive amount of pressure. It's that fundamental understanding that people don't get. So they start creating things like, oh, I'm just going to shoot a laser through the gas in the environment and then through this piece of glass over here and into this little pressurized tube and then out of the glass over here and into this thing over here where it reflects over here, right? But you didn't even take into an account that you just went through a gas environment. You just said, well, it doesn't matter. Well, you fail because anything you get out of that experiment was now trash because you didn't take the conditions into account. That's what I mean by environmental condition. Once you realize it, you understand what you're in. Anti-gravity is not hard. This is not a difficult concept. If you understand how to structure the air, you've already got it. You see, we do it in weather balloons all the time. We structure the air in the weather balloon, right? It creates a gradient inside the weather balloon. It creates pressure inside of it, and it creates gradients in the gas, okay? All right, some are heated, okay, some are not. But yeah, but that's the point, isn't it? It's working on the same system that's going on because it's in gas. You got to realize that it's in gas. Anti-gravity, structure the air. Not a problem. We can move it. Why does it have no problem going between the air and the water? Because it's just a gradient, okay, to them. They could care less, okay? All they have to do is change the pressure differential inside the energy bubble that they're going through, and they go right through it, okay? It's not that difficult to understand. What's the hardest thing to understand is to take somebody's mind and empty it of all the gibberish that makes you fight between each other on all the garbage that they come up with. I mean, they have several theories out there. You ever hear somebody go, "Oh, if it's not Newtonian physics, then we don't have it." But what about the electrical energy effects that goes on? Well, no, that's not part of physics. But you use energy in order to create all your physics in Newtonian physics, don't you? Yeah. Well, that's the problem, isn't it? You are so ignorant not to see that, to try to bash something that it's actually part of what your physics are.
Right,
It
right. I
is,
mean, talk about drawing yourself a box around
yeah.
yourself, and then looking for the answer that's outside of that box, and then wondering why you can't find it. I mean, you know, Jeffrey says in the chat, he says, to me, anti-gravity is going against gravity, and anti-gravity to me is built with propellers and jet rocket propulsion systems. Now, funny thing is, hold on, I don't disagree with him. I mean, right now, that's
It's
what
not anti-gravity though.
it
It's
is.
not what the
Well,
meaning of it
okay.
is.
No, okay. First of all, rockets are not anti-gravity. Okay, but airplanes and helicopters kind of are. The only thing is that they're mechanical. Okay, and they're inertial dependent. Okay, and that's the biggest problem is that they're not purely anti-gravitic and they are inertial dependent. They only have a partial decoupling from the environment, okay, which is what allows them to, to have lift, okay. But the thing is that lift, okay, without the need of a forward motion multiplier or in like a helicopter's um, point, they have to have counter force rotations, okay, and thrust, okay, in order to compensate, which is why the everything pitches and rolls, right? It's all to do with the gyroscopic relation. Nonetheless, don't want to go all too down that. The
No,
fact is
you're
that
creating pressure
it's
gradient in the air. That's it.
yeah, well, right, exactly. But the thing is that you're getting a part of it enough to get you off the ground. And the only way that you could do it mechanically in that way is by using forward inertia for the most part as a multiplier. And that's it. Like if you're going to do it electromagnetically, you're going to reach the highest efficiencies. You're going to have the ability to do things that you wouldn't do before because there's a much higher ability at that point to actually decouple. And once that decoupling occurs, you don't use propulsion in a traditional sense to move. Okay, you use like field modulation, where small differences of pressure gradients on one part or another, okay, is going to lead to a great deal of acceleration because you have literally the entire environment start to collapse on one side, um, of you, pushing you opposite, right? Equal and opposite reaction. Well, what happens when you have this huge collapse event occur? in one segment just by manipulating your field geometry. That's the point, right?
No, I get it.
Your new center of gravity. You see, the reason it's anti-gravity is because there is still gravity and you still have gravity, but you have a different set locality in the sense of you have a different center of gravity than that of your ambient environment. See, you can't have a different center of gravity than that of your ambient environment and still be local to it. Now, that's why things that are gyroscopic, okay, start to feel like they could easily become antigravitic, right? And that's the relevance. You know, when you spin something fast enough in a couple of axes, you get a great deal of stability. Gravity changes because it no longer is sharing the same center of. Well, in that case, it is. It needs one more vector of motion, really, at the same levels, right?
It's creating its own center of mass.
Then be decoupled.
No, it's creating its own center of mass. It's structuring on the inside. No, I understand that.
Yeah, exactly.
But most people do it when they create one rotation and think they're going to get it to work. Even the Bible says it's 3. I mean, I don't know what to tell people about that, but they should understand what they're trying to do, because the 3 wheels is what I'm referring to. If you ever looked it up, anyway.
Well, I mean, there's relevance to that though, because if your gyroscope moves relative to the central axis point, right, you notice that you could start moving it off to the side and stuff, and it still stays, you know, like perpendicular or whatever to you know, the central axis point.
Here's what gets me: people wonder if inertia is still part of it. And let's just think about this again. Do you feel inertia when you're in the solar system? Okay. Does the sun feel it inside the bubble it's created? Not really. Not the center of the sun. It doesn't feel it. Does your planet feel it? Okay. If you're standing there on the planet, do you feel inertia while you're inside of it? No, not at all. Okay. Here's the thing. If you're creating your own gravitational condition, there is no inertia. Okay. You're inside of something that has the fields going on the outside, which the energy is on the outside. So if you're on the outside of the observer, on the outside, you would say there is. If you're on the inside, there's none. That's why they have the time dilation that goes on in there. They're moving too fast in the energy while your eyes pick it up so slowly. It's, you know, Einstein said it right when he did that one. I'll be honest with you. So, yeah.
Yeah.
I don't know, Joe.
Not to get tied up in the gyroscope thing too much, right? But the one guy was showing it at one point, you know, where like if you had it free floating, you had the 2 flywheels going, you had them at a pivoting point, right, where they could dynamically change their own center of gravity. Mind you, they're already doing it. Now it's about taking what's around it into that field. Now, in order to do that, you need to be able to have another spinning vector, because if you notice the standard gyroscope or its top or anything that just spins, right, with centrifugal force, right, it's going to be stable on one point axis, right? But in order to get it stable and free on that other axis, you need another equally dense rotation.
Okay, it's like the wheel experiment in physics. You tie it to a string, you rotate the wheel around, right? But then there's a pressure point that comes to it. You're saying add 2 more wheels, and then you can make the pressure point the center, and then it should float, you know, in the air. It's what it should do. I understand that. It's. I don't think anybody's ever tried to get it to work that way.
Well, there was one guy in Scotland that kind of sort of did ish. He did pretty good.
Did you get it to stay up in the air?
He got it to lift, but just like the thing about what he did, I don't think he understood the component that he was missing. Very, very smart guy. Okay. But he missed one critical component, which is that in order for the resistance to be broken to allow for the inertial force of the initial pull that caused it in the first place to sustain, okay, you would need AC relationship, right? So one would have to be in frequency and resonance back and forth that way that they are coupled, because then they would lose the resistance between both sides of the equation. So he was able to get the thing to lift up on a rail. Okay, so it would lift up. It would, what it did was he would spin both gyros at a time, and the gyros were attached to a pivoting arm that would go like this, right, along a central axis point that then had a rail down the center. And what would happen is, as they sped up, they would rise, and then as they rose, because they were able to pivot, you see, they had a common central connection that they were then able to pull up on that central axis point,
Mm-hmm.
effectively levitating the thing by using that. But again, it would start to rise a little bit. He'd be like, look, I got 2-3 inches up, and then it would down. Why? Because the two sides were not in this AC resonant relationship where it's pulsing like this in its frequency. Because even though like you could think of spin as an RPM, and therefore more of an analogy to like a DC state, right? You know, it's sort of like one of these things where you need things to be the RPMs, and every imperfection needs to be at this push and pull state. So those points have to cross at opposite times of the wheel. So like how we were talking about the electrical analogy to this would be an asymmetric capacitor, right? There would actually have to be an intentional imbalance in the system, okay, to be able to then create the take it from that DC state where it's like, okay, the line's crossing, to it's crossing and bump, right? And then on the opposite side, it's crossing and bump. And each time you do that, then it would be able to probably actually couple in the center. And it's that coupling that would then break the resistance, because now it would almost be quasi perpetual motion. Now, whether or not you could do it mechanically, whatever, but your efficiency would go through the roof. So rather than it go up 2 inches for a few seconds and then start to fall, you might be able to get it up 6 inches or 8 inches or 10 inches. That's what she said. And she got nice knockers. And then, if it's going back and forth, maybe the last minute. Right? I mean, and that's the difference. Maybe it's not indefinite, but you end up creating that coupling effect, lower resistance, resonance between them, and then, it would be able to be up. But I think they killed that guy off before he had a chance to figure any of that shit out. And burn on his team. So,
I want to say thank you to Ulysses, man. Thank you very much, brother. I appreciate
right on, dude. Always. Thank you so much.
I think part of it, Joe, is, I don't want to say this. It's the equalized pressure in the two, with one of the three being the balance point. You know what I mean? And just like we talked about, when you tip the balance, then you can go up and then level back out and up and level back out. I don't know if you can get the steady rise without energy being part of the equation, as in, a field around it. But then again, the RPM in rotation should give you a frequency which should build the field. Yeah. And then that means that each one being a different size, even if they're rotated at the same speed, would be a different gradient in that field. So it should be able to create the three fields necessary for coupling.
Yeah.
So yeah,
I mean, that imbalance.
You probably did.
About, by the way, that imbalance and in that time sequence to lead to the coupling. This is the reason why reported UFOs, right? They do the bounce, man. They do the wobble and the bounce. This is why, because even if you simulate it, with energy and energy vectoring, it's still those same resonant imbalances. It's the same as the light. Everything's crossing, but the frequencies are different. So the frequencies are crossing over resonantly, but at the same time, there's times where one's falling out and one's falling in. and then they come back together, falling out, falling in, come back together. And when I did the drawing of the thing that I said, where you take the Tesla coil and you put it upside down and do all the stupid bullshit that I said, and RAV and this and that, but that was the whole entire point, right? You know that it's all in resonance because it's all from one initial source, and then it's being broken apart from there based on its components, being revectored, reutilized, and then being broken out based on its environmental factors, which means that every single thing that pulls gives a push, and everything that pushes
Oh
gives
yeah.
a pull. And but it's not happening at the same timing because there's resistance variation, right? And it's opposite one side and the other. Does it sound familiar? Like, this is what I'm saying. It's all the same. And I've been saying it since we didn't even know what it's all the same meant, but I just knew that it was all the same. Like,
I'm there with you, Joe.
right
I'm
on.
there with you. Yeah, dude, 0 point's fascinating when you actually get a hold of it. So, how do I say this? It goes through everything. So just understand that. If you actually created it, you're going to walk away then with a different experience than you would sitting next to, some static electricity machine. Just understand what I'm saying. It'll be completely different to you. It'll go through everything. It'll go through the lead. It'll go through the metal. It doesn't care any part of anything. It just doesn't care. It goes through it. There's very few ways of containing it. And once you realize that, you realize you have a different animal on your hands than the one you thought you did. And that would be the difference between creating it and not creating it, and knowing that simple fact. If you created it, you should walk away going, oh my God, it goes through everything and I cannot stop it. When you don't create it, it's going to create a charge state on the item around you. And then that in itself is going to cause a condition on that plate. This stuff doesn't create the condition on a plate. It goes through it. It goes right through it. And it did it to me 100 million times. It goes right through my hand. It doesn't care. The energy shows up on the other side.
So let me ask you this, and I have no evidence for this, but I want to see what you think. The most volatile elements and compounds, the ones that are the most reactive, okay? If you were to look at their native resonant frequencies, I would make a hypothesis that there's something to do with a prime number being their resonant frequency. Okay, because if you think about it, nothing falls into resonance with it and it becomes immediately deconstructed. So as soon as it comes into interaction with some other type of material, it's going to want to change. So it reacts bang right with it and then has to combine with it because it's being forced into some other kind of resonance that it could just simply never be a part of. And then you look at something like oxygen, on the other hand, and if you were to look at its resonant frequency, I would bet you that that's the one thing. Its resonant frequency is like a number that fits into like every slot. You know what I mean? And these resonant frequencies, if you don't get what I'm putting down, it also probably has to do with its electron proton structure.
Yeah.
So, and the offset beat frequencies between them. So, I'm just planting some seeds of guessing here, but it feels like it's right. It feels like it's right.
I want to thank Lightspeed out there. He gifted one Old Man's Build membership. And I also want to thank Yanni out there. He gifted 5 Old Man Build memberships as well. Yanni, I also want to say a personal thank you. You talked to Dispatch over the last couple of days, and Dispatch brought me over one of his famous sandwiches, which was really, really good. And he brought one for Bernie as well when he was here. So I say thank you to Dispatch and thank you for Yanni out there, man, for taking care of me on that.
Right.
It was a really cool thing, man, to do. Appreciate you guys both for that.
Very cool. Yeah, and Yanni had a good comment a second ago. Give them some time here. Good to see you as usual. Oh yeah, he had said something about these beat frequencies, being akin to like binaural beats,
There we go, right here.
and
Sounds similar to beat
yeah,
hertz or binaural.
yeah,
Absolutely.
and that's exactly the point because it works exactly that same way. You're introducing high vibrational, high energy states by coming in tune with
Yeah.
closer to the ambient points, right? The lowest frequencies that you could possibly have, okay, are closer to the highest frequencies that you could possibly measure, okay, than they are anything middle of the band. That's that's just the bottom line. That goes on a loop, and that loop is the Planck scale, and that loop is the hot and the cold, and how it all breaks down, and how when you push the cold more on one side, you end up with the dematerialization, the same as you end up with dematerialization on the other side. You just don't see it the same way, because one appears to be a cascading effect, on the hot side of things, right? So it seems to be a rolling, self-perpetuating dematerialization.
Yeah, but
Um,
I agree with you on both sides of it. Well, it's like, okay, when you take that orgonite thing or the wire you put in the ground, right? It builds that vortex above it. Well, it's building one below it. You know what I mean? Every time.
every time
So,
it's got to be right. It's got to be.
yeah. So the orgonite, mention orgonite, Nate Center shows up. Right on, brother. But it's absolutely true. It's building the vortex in one side and the other, and one side of it can break things apart while the other side rebuilds them. So that's why you get the energy exchange between the two, and you get the ground to work differently for you, and it's able to grow plants better.
That's it.
Right on, man. Sorry.
We've been on a roll for an hour 45, man. We've had no shortage of interesting and
Oh no, we've been on it today, man.
Yeah.
Yeah, it's just interesting how things work, man. What's up over Unity Research Channel?
Going on.
Oh man.
All right, this one's for over your Unity research channel. Generators are 0-point energy per meter. And
Generator is 0-point energy.
generators are 0-point energy per meter. And airplanes are anti-gravity per meter.
Why would you say that to him? Is you did some video on it or something?
No. I'm just saying.
Okay.
I'm just saying, like, you could research it up and down, man. And it's like,
No.
when it comes down to is you're all opening up the energy potentials from the same place. It's just a matter of how do you want to do it. And you want to spin magnets around, and you, like I said before, you're taking a locked position of a four-dimensional object, and then you're putting it in motion, adding that extra vectoring, and all of a sudden you've reduced the resistance between you and the energy potential of, the etheric energy of the 0-point field. So, as soon as you bring that into a relationship with coils that are then able to, reach into an excitation mode and then create, vectoring of that potential, now all of a sudden you have a current, and that current is electricity. So,
all right, Joe. Over Unity Channel, if you're out there, here you go. Come up and join us and tell us what you got, man.
right on. Do it.
There you go. I'll put up the StreamYard link right there for you. Jump in here. Yeah, it's kind of interesting, man. I love to get at other aspects of this, man, because everybody's got a little part.
See, he's on to it. I've heard of this because that's how you could fit so much fuel into the wings of an airplane. Yeah, damn right. That's because those are the uncoupled, anti-gravitational fields because the where the differentials are. You have all the up press and down swooping there, so you can put as much weight as you want. Really.
I heard that SR-71 leaks like a sieve when it's on the ground, but when it's up in the air, it's airtight, man.
Yep. right. The problem is if it's not leaking. I've heard that before. They're like, oh, if you don't see anything, it's because it ran out of whatever it was leaking. So you might want to check that. I've heard that before. Yeah,
That's crazy.
yeah, man.
Oh man, yeah, I was tripped out on that. They got one over here at the March Air Force Base Museum, man, by my house. It's oh, dude, it's really awesome to look at, bro. I just remember it from like GI Joe back in the day. You know what I mean? And then you see it on the news once in a while, and then boom, there's one right there where I can actually see it. It was cool.
So,
They had a bunch of World War II planes over there that they restore. So you always get like flybys. And then all of a sudden you start seeing 3-wing planes, and you're like, what the world's going? They're just restoring something and you got to be able to fly or something. It's pretty awesome to see, man. So
damn
I
right.
guess it's like other people that goes to the air show. You know what I mean? I just get one like driving over or flying over my house all the time.
That's cool. Yeah, we don't have too much of that going around over here these days.
Nothing
Probably.
like that, huh?
No, you know what? When I used to work for another company and stuff, we used to do our advanced training that we'd have to go through down in Virginia Beach. So it was actually pretty nice. They put us up on the Marriott on the boardwalk in Virginia Beach for like a couple of weeks at a clip to go attend our, schooling and stuff that we had to do periodically. And
Nice.
when you're down there, it's right out in Norfolk and stuff. So you get all the Navy fighters, blasting around doing all sorts of shit 24/7. You get to see some pretty rad stuff because they run their drills right over the ocean. A lot of times, and yeah, not something I get to see all the time, but it's pretty cool.
Right on, brother. Yeah, I'd like to see some of the newer planes they're coming out with. What do they call them? 6th-generation fighters. See, that would just be awesome.
I mean, there's a lot of people out there that said that those have been flying for the better part of a decade already. So,
I don't doubt that.
whether or not they're putting them into the full-on production just now is another story, but
Well, yeah, I mean, dude, the speeds those things must be able to reach. I mean, think about it. The B-2 uses the electricity on the outside in order to get to the environment faster. You know what I mean? So, what did they come up with next? That's what's I'm curious to see.
Well,
I know for another 20 years.
I think that we're at the point now where, like, the weird thing is that, like, it's whatever we have in development now is like some other kind of level that we just we haven't even opened the door to see what the next door is, or it's at the highest point of where that next door, like where that door is for us. Like, because realistically, the technology that they're willing to talk about now is straight out of like 85 Tom Beard, in his lectures. It was all the stuff he was talking about. I can't hear them talk about on the news like an F-18 Growler without me thinking about Tom Beard. I'm like all day long. All day long. I'm like, oh, wow. So you're collapsing somebody's radar signal and sending it back to them, you dickbag, and blowing the fucking thing up for reals,
Yeah. Oh, yeah.
Because all they're doing is they're collapsing the signal and then sending it back, and then it causes a cascade overload of all the electronics, and then it's done though. Return to sender, bitch. Yeah. Hey, what's going on, man?
Hey, what's going on, guys? Good to see you. Am I coming in loud and clear?
Yeah, we hear you good.
Yeah, we hear you good.
Awesome. No feedback or anything?
No, we're good.
Sounds good to me.
Awesome. Yeah, I was hearing y'all's discussion today. I just jumped in. We're talking about anti-gravity stuff. I had a question for you, Nathan, or I was curious. Well, you know about Alexei Chekurkov, the guy who like kind of started all this, right? I mean, I seen those videos years ago when they came out, and I'm not sure. I'm pretty sure you're aware of it, but I think it's still on his YouTube channel. But he had put out some schematics on how to build his device, like translated in English in PDF form and stuff. But I don't know if you've ever got to look at those. If not, I
Uh-huh.
just wanted to throw it out there.
Yeah, definitely got to look at him, and Charlie C bought his original gravity flyer, so we got to find all the parts, everything he used to construct it, every measurement.
Wow. So he uses texturized aluminum, from what I remember, which I don't know if that's a key thing, but
Well, he uses
uh,
so flat aluminum in the center, and the two discs are textured, and the reason is he gets a higher capacitance value because of the valleys inside the textured stuff.
Yeah, it's surface area.
oh well. Yeah, I've always wanted to build that, but I never got around to that device. But I was like collecting data on that to do that one day. But I really give you props for sticking with it all these years, and it's
Well,
it is. Go ahead. Sorry.
oh, I was just gonna say it's a great way to teach people how electricity works and things maneuver. If nothing else, if that's all you get out of it, it's an outstanding piece of machinery to do that. But I still got hopes, man. I'm crossing my fingers for the next couple tests that we can get this thing going, and show the different things, and Lightspeed's out there going to hook us up with all the things to see it all. And then we got that mirror that I got sitting right over here. I'm building the STLs for it. I think there's more to it, man, than people understand. But you know what I mean? It's always
Well,
intriguing
there
when
is
you
more
build
to
one.
it, Nathan,
Yes, sir.
but he's also stubborn as fuck, this guy.
Maybe I
I'm all
don't show
kinds of
everything I
stubborn too,
should.
man. I don't give up either, man. I just keep getting back up. Because I know, I can pull it off. I can do it. I've seen it. Bedini's done it. Newman did it. Like, there's a lot of people that achieved it, and it's not that the secrets are buried. It's just, you have to have the right mindset to understand what they were doing, and you know, and just put the pieces back together and rebuild it.
Pretty much.
Well, yeah, you pretty much have to learn electricity a little bit differently than they teach you in school. And if you could do that, and then you can keep your mind open instead of filling it up, you know what I mean, with everything else, then you have a chance. And that's what they were doing. If you notice, they're not really affluent in all the language that physics would have, but they try to keep it on a common level. And I think that has to do with the heart of it. You need to understand things differently than what physics says, or else you're just going to be in roadblock after roadblock after roadblock.
Yeah,
Right.
big key is just definitely to just almost rinse your head. Like, yeah, electricity is a component of it because it's the means that we're using to hopefully achieve an end. But at the end of the day, it's just about energy and the different types of energy and how they interact and exchange. And really, the interaction, that's the big part. Because if you get everything to start interacting together, the synchronicity, with synchronicity, then you have a system that's at a high degree of efficiency. And if you're able to maintain that efficiency while bringing more energy in to increase your energy density levels, and then start to affect your environment around you, well, then all of a sudden the environmental differentials start to become significantly different. And then once you come across those thresholds, your environment no longer has the direct access point to the interaction of that which it's creating. And that's the motherfucking key. That's it. Because that breaks locality. You see, you no longer are local to your environment at that point. You're moving your environment around you. And you are in a cavitation bubble, effectively. Yeah, when you're in a cavitation bubble, it's really, really cool. And it's something that they see in UFO research, like when some of them are woo and other ones are good or whatever. But what you notice is that, there's a semblance of kind of environmental distortion around there. But then when they take off, they go metallic. They turn like a bubble, all of them, always. Okay.
Always.
And you really can't see into the bubble and you really can't see through the bubble, but yet it appears sort of transparent. But it also appears really metallic. It's sort of strange. It's like looking at a bead of mercury. And why is that? Because, well, when you create the cavitation bubble, that's what it is. Like you're in there, but nothing outside can really see you in there. And it's reflecting the entire environment around it because, there's nothing to transmit through. Everything that goes in, is being pushed away before it goes in. So nothing is being transmitted through it. So what you end up seeing is a reflection of the surface, the barrier surface, of where the locality is broken, which makes it look like a metallic sphere or blob or whatever, a dynamic blob. Does that make sense?
Does this have anything to do with the Philadelphia experiment by
I mean,
chance or no?
I mean, it sure does. I mean, whether you subscribe, I don't know. Like, I never know if I subscribe to the truth of it or not. I'd love to believe the experiment and Montauk Project and all that stuff was 100% legit, but at the same time, like, I don't know. It's
Like
got
just
elements of bullshit to it, but
the
yeah,
methods that they may have been using to
The
make the
methods,
ship
yeah.
disappear, like were they trying to actually make it like what you're saying?
right on. The
You
science
know,
is good. Yes, the science is good. Let's put it that way. The effect and the science is good, but whether or not they actually did it when they said they did in that way, I don't know.
right?
So what are
I'll
you
be
working
honest,
on
like
over there?
What?
me, well, I've been kind of off the air because I've been moving. I finished moving, and I've got a new shed. I've got to put up some lights, and I got to get my shelves up on the walls. And I'm still in the organizing phase right now. But what I was last working on at the other location where I was living was I was working on this coil shorting circuitry with Doug Conzen, and I've been working with Doug Conzen kind of behind the scenes for a while, and he's been developing circuits too. Similar, I got made some circuits inspired by him. And a matter of fact, he had sent me some circuits, some of his pulse motor circuits and his shorting circuits, and then I went ahead and took it in a different direction. What I want to do is this: it's like, you have a Bedini motor. Let's say you have 2 or 4 coils, however many you want for the drive. We're gonna use a Bedini motor as a motor. Like Bedini says, you can only take 23% of mechanical energy, right? Maybe you could take a little bit more if your torque is better, or if you're using north-south magnets, or whatever your setup is, right? Really, I'm just concerned about the speed of the motor. I want to get around like 2,000, 3,000 RPMs on a Bedini motor, which is,
Wow.
that's pretty fast.
That's fast.
Maybe a little bit less actually, but so I have like man, I wish I could show y'all guys this. I will show y'all pretty soon. I need to get my shop in order. But best way to explain it, you got a Bedini motor on the bottom floor, I call it, the bottom platform that houses the Bedini motor. You're charging batteries, you're running off a run battery, and on the same shaft there's another platform on the top that has 8 generator coils. And these are bifilar coils, and the coils are connected to its own individual circuit, and it's a shorting circuit that I've made several different variants of this, but the simplest one is like using a trigger coil to activate a transistor like a normal Bedini circuit. But between the collector and the emitter, we actually have the power winding across the collector and the emitter to dead short across that whenever the trigger activates the transistor. And whenever that happens, the coil shorts, and you can move the trigger coil, but I'll let you know, it has to be a separate trigger coil. It will not work if you use the same trigger coil from the same bifilar coil. It cancels itself out. So you just get a separate trigger coil, and it's better that way too, because you need to be able to move this to change the timing, to retard and advance the timing of when you want the short to occur. Yeah, and like you get this high voltage flyback spike just like Bedini, and I think it's amazing, man. Like I wish I didn't glue ferrite rods into my Bedini generator coils a long time ago because I can't take them out now, but I've been needing to get back to the bench to rewind some fresh generator coils for this setup. But I've got some amazing stuff coming y'all's way, man. I bought a CNC machine. It's a what is it? A Genmitsu 4040 Pro. I've got the A-axis add on to, and like I was cutting rotors out and motor parts, and I want to start making these motor kits and like maybe selling them, to make a little bit of money to get by. But yeah, the generator shorting circuit, I want to short 8 coils out on top individually because I want to get 8 spikes per revolution, and I want to like combine all those spikes into like a cap dumping circuit or put it directly into a battery, and I want it to go back into the run battery. That's where I'm going with this. I want to loop it. I want to close the loop where we can use all of that charging output from the Bedini device as normal, but the run battery won't run down anymore. You don't have to swap the batteries around. That's kind of where I'm at, basically, I guess. And I've made different variations. I've got the transistor version, I'm gonna get into like, okay, what's better, shorting them individually, getting more spike density, or shorting them all in series. You get a higher voltage, but it's only 1 volt, 1 pulse per revolution, maybe. Possibly, if I put a diode in each one, I can get separate pulses. I don't know, but I'm gonna try all these different configurations to see which one is the best result for the output. And then I moved on to MOSFETs and Hall effect sensors with gate drivers, and me and Doug have worked together. He taught me a lot too. I've been talking to Grok. I was talking to GPT to advance my knowledge on electronic components to make these more advanced circuits. So that's kind of where I'm at, I guess. But I have some other ideas too that you might be interested in.
I got one for you. It's probably easy to help you with your timing. If you remember an old Chevy where you basically put a timing light on it and you had a spot on there where it tells you in between two things which is advanced and which one's in the negative. If you set up a laser in order for it to blink every time it goes around, you could set up a timing light basically on it so that you can advance the timing and retard the timing on the machine immediately.
Are you talking about like opto coupling? Not opto coupling. Sorry, opto sensors, or what do you call them?
It'd basically be just like a timing light. Is what you're using a laser to create a timing light so that you can advance or retard the timing.
That'd be pretty cool. Well, the next stage for my circuit is I was gonna add a PWM to widen, and I can adjust the pulse width of the triggering, and then I was gonna make a frequency generator maybe, and implement that into the circuit so I can adjust the exact pulse width I want. And
that'd be good.
I'm gonna open source all this stuff too. I want to release the circuit when it's working properly. Like, I don't want anybody, dude. I've burned so many MOSFETs out. Like, it's insane, dude. I mean, they say if you're not burning transistors, you're not experimenting, right? But it's costing.
Try and find out.
Try and find out. All right.
That's my motto. I do a lot of frying.
Yeah, man. I'm gonna probably like all these dead components. I'm gonna start hanging up like little portraits in my lab, like of circuits, but actually put the dead components there.
Nice.
Yeah, right. You got to like a little board, and then like paint the board fancy, and then you can take all your dead circuits and just like hot glue gun them. Give it
even like I'll draw it. Like I'll even solder the wires, jumper them.
Oh, nice.
Like this is how it's wired, crudely, but
you'll have to put a plaque on it when you're done, when you got a success. You know what I mean?
Yeah.
You put the date on it. That'd be awesome.
Just a quick 5-minute arts and crafts.
That's it.
I'm there with you,
the
man.
work area keeps you inspired. It adds like a little ray of sunshine to blowing shit up. It's like, I get to add something to the piece.
Yeah.
I got a box of ZVSs sitting over here, man, in a big tub that basically is like my failure zone, and it's some offsets that go bad, and you can't exactly switch them all out because you start breaking the boards. So at some point, I think I'm going to try to work on it, but I never get around to it. But there's probably like 30 of them in there when I first started, and Sean used to laugh at me because my whole Tesla coil would be on fire right? You see smoke everywhere, and I'm just walking over calmly to it. Man, I must have burned like 20 of those things in the first week.
Man, I got 3 brand new ZVSs I haven't used yet. I know there's like 2 different types. There's like one that has like the common ground in the middle, then you have the 2 outer connections, right?
Hmm.
And then there's some that just have 2 connections, which it probably has the common ground in there somewhere in the circuit, but they just have like 2 connections. Those, but I have the ones that have the 3, and then I have the other one that has the 2. And well, the reason I bought these is because I was building those. I call them Inky coils because if you've heard of a channel called William Inky, he was
Hmm.
building a lot of those TPU coils. He calls them, and they're the ones that go on top of like the cooktops, the induction cookers. I don't know if you ever heard of those.
Yes, I
Induction
have.
cooker?
Like
Yeah.
where basically you can get a primary coil and power it off a ZVS. That's actually the way you want to do it. But if you didn't have that, you can just use your an induction cooker, and it's got a ZVS type circuit in there. And matter of fact, Doug Conzen, do y'all know of Doug Conzen? I'm pretty sure
Not
Conehead.
sure.
He goes by Conehead. He's been in the energy community for a long time. He had made a
Really?
video. Yeah, he's been since way back then. He knows a lot of people. I talked to him. I need to catch up with him, but he's a good friend of mine. He's been doing a lot of research with the TPU coil stuff, and if you've ever seen inside of a cooktop, he got rid of all of the unnecessary components in there, like all the safety features and all that, and he just made. Yeah, he just made like a raw like a ZVS circuit like that's inside of a cooktop. A lot of people
Nice.
haven't really done that, but
Yeah,
I think that's pretty cool.
but all that sounds like to me is like doing a Faraday induction furnace. Because as soon as you get rid of the safeguard, you start forcing resonant oscillation. Through
Yeah.
induction.
Well, he's got like a frequency generator to it. He's got a frequency generator. He's setting the frequency. They usually work at like 25 kilohertz, like a little bit higher. And he used all the same capacitors and everything and inductors for the ZVS part of it.
Nice.
He just rewired. He basically wired it exactly the same as the cooktop circuitry, but he got rid of the cooktop like pulsing part of it that triggers everything on,
Yeah,
right?
that's the temperature control because that's how they modulate it. They don't do it based on the intensity.
Right. Well, because some of those cooktops they just pulse on and off,
Yeah.
on and off. You've seen
Right.
people light up halogen lights and stuff, right? But they don't. The only way to consistently get it to stay on is like on setting 4 or 5, and higher, and but they draw more power and maybe the switching isn't as clean or I'm not sure. But yeah, he wanted to just make it more compact. I don't know,
All right.
just putting that out
Before we
there.
go too much further, hold on. Jarvis,
Go ahead.
bro, man, the legend.
What's up, Jarvis?
It's good to see you guys.
Hey, Jarvis, nice to meet you.
Hey, nice to
I
meet
like your
you.
background. It reminds me of like Iron Man or something.
Yeah, I'm in the spaceship.
Oh,
Nice.
Yeah.
I
Love
thought
it.
you were at Pulse over
Yeah.
at Mission Control.
Well, I'm in Artemis right now, so it's
Oh.
Artemis 3.
Nice.
Going around the moon, huh?
Yeah. You're on the dark side of the moon.
I'm in my storage shed. It's so pretty, so I don't want to turn on my camera. No, just kidding.
Oh, nice.
It is kind of a mess, though. I'll turn on my camera. I mean, I don't really mind. It's just
Yeah, no, that's when
it's
you got to
opposite.
take the rag of ether, and you hit a rag with it real
gotta
quick, and you whack yourself in the face with it a couple times, and then you see reality, and then you come back and tell me about it.
Yeah, what's up, dude? It's good to see
What's
you.
up, brother?
That's much better. It's hard, like when people don't show themselves.
Let me
even with
turn
the
it this way. Is that better? Does that?
Yeah.
Yeah,
That's
you're good.
Oh, there you go. You're good.
Perfect.
The keyboard was
Okay,
cool,
cool.
too. Can you actually?
It's a nice
play
shed,
the keyboard?
man.
Yeah, no, it is. Yeah.
Thanks, man. Yeah, it's a new shop. It's kind of a work in progress. Got some lights up, but it's a mess. It's a mess in here. But yeah, it's getting there.
What do you think the most promising thing you've seen in Over Unity is so far?
Ah, man, there's been quite a few things. I watch a lot of experimenters, to be honest. Like I was just talking about Doug Conzen a while back. He had made a rotorverter. He tuned a rotorverter, and basically it's running off of a little stat power inverter. It's basically a little 50-watt passively cooled inverter that doesn't have any fans to kick on to consume more power from the run battery. So that's why he chose to use that, and it's kind of like got a DC to DC buck boost situation going on with the circuitry. It's not like a typical inverter. I would say that he's explained it to me. There's like a U.S. patent on it too about it, but he chose to use that one. I don't know if you have to use that one exactly, but I actually hunted two of them down, and I still want to get to that. But yeah, he got a regular 7 amp hour lead acid battery with compared what is it? He's got two supercapacitors, 16 volt, 500 farads. Those long blue capacitor banks, and he's got them in parallel with the primary. And he's running the rotorverter off the inverter, and then he has a transformer vectored in, kind of like running in series off one of the legs, and he's got the secondary going to a bridge rectifier charging back into the battery that's running it, and it's actually charging itself. It really was charging itself.
Sounds like a Benitez system. Have you heard of that?
Carlos F. Benitez, yeah.
Yeah. Kind of sounds like that, but instead of using two batteries, he's just feeding it back to the same battery.
In a way, yeah. Yeah, Carlos F. Benitez, I've watched a lot of the stuff on him and the mechanical commutation devices he made back then to swap all the batteries. That was pretty interesting.
Well, the key,
for his time, you know.
The key, he used mercury lamps, which are extremely low resistance rectifiers. Like every rectifier we use, you're at least going to get like a 0.6 volt drop on silicon, or germanium maybe 0.3 volt drop. Like the mercury vapor lamps was practically no drop on it, so he could have a reactive power and rectify it into a bridge rectifier, much more efficiently using those. When they were using tube technology back then, it was a little bit better in some ways than the solid state. But
wow,
it's similar though, because like Nikola Tesla used magnetic diodes. So I think that would be the best practical way these days. Like what he would do is he would use the counteraction or the action of the magnetic field through, like, I wish I could show you the pattern, but he basically used magnetic fields to act as a diode to rectify the system.
I've actually seen some videos where some people made magnetic diodes a while back, and like basically it's like a series of coils, or they're wound in a certain way where it only will let current flow in one way and not the other, or something like that. But that's interesting.
You want as low as resistance as possible on rectification, and
you're talking about like those old type of diodes they kind of look like tubes, like vacuum tubes in a way.
Mercury. But it's hard to find now. Like the actual tubes he used were mercury valve tubes, and he actually used the spark system was a special spark system. Like it was after Tesla, and he claimed it, but Tesla basically created it. It looks like a hairpin type of spark system, but it's magnetically quenched. So
like if you put a magnet on a or near, like it can definitely amplify the spark, or even wind. I think I've heard that, I've seen too over time.
Yeah, it was basically a magnetically quenched spark gap hairpin circuit that oscillated, and then he rectified it with mercury tubes, if that makes sense.
You know what, that sounds familiar. Like it sounds familiar to me, and I could be very wrong, but it sounds like early CRTs and how they used to use the the electron gun, the amplification of it going into the electron gun as it starts scanning. It's a very similar process, I'm pretty sure. In fact, I think that some of those mercury vapor tubes used to be a major component of the amplification system going in.
Well, the thing
They
is,
stopped using them in like maybe the 70s, you know?
well, the thing is, you can amplify power, but you can't amplify energy, and everybody's focused on the energy. A laser amplifies power. It's a
Mhm.
parametric. Any parametric oscillator you can amplify power with, right? And people are focused on the energy. You don't want to amplify energy because you're not going to do that. Energy is an ability. It's always going to be
I
what
agree.
it is.
Mhm.
So if you focus on power and you use parametric oscillators or lasers, that's a classic example of a parametric oscillator.
My brain
Then-
works so opposite that though. I always have to start with energy to
Well,
be able to realize what the power is going to do.
but the power is the energy over time. That's all you got to do is
Yeah,
take the
that is
energy and
true.
divide it by the rate of change, right? That's all power is. You take
Right,
the energy.
but it's the change of the power over that time and how you're doing it that ultimately leads to what your power is.
The confusing
so important.
thing is you got real power, you got reactive power, and you got apparent power. Okay.
Uh-huh. Yeah.
Steinmetz with phasor systems. Okay. Steinmetz laid this out for us. So that gets confusing, but the reactive power can be converted into real power if you know how to do it.
Right.
That's what Benitez was doing, but you need low resistance rectifiers, and an oscillator like the hairpin. The hairpin's really electroline, if you want to get technical.
There could be some other ways to convert it too. I mean, like I have a friend named Jason Illard. I don't know if y'all know him. He's a good guy, great experimenter. He knows K Energy, some other people, and he was building a PCB board that he built, basically replicating what Robert Murray Smith had talked about. Was it like a year and a half ago now? I think he was talking about the fractal capacitor. And you basically, it's an idea where you charge a bunch of capacitors in series because there's less resistance, and then you discharge them all in parallel through a series of diodes connected a certain way. It like discharges them in parallel, and you get a lot of amperage with no, And if you make a circuit where you can charge the capacitor in series, then when you're going to put it in parallel, you disconnect the charging to the capacitor, you isolate it. And that's what Doug Conzen was talking about. And basically, then you can dump it into any load you want, and it won't put any lens or braking on the motor or the generator. It won't put a load on the the prime mover. But there's there's these different steps to isolate it like that. And
I
you
wanted
can
to throw this in there before we lose it because John said something really, really interesting, and I was like total chef's kiss to that. He's like, well, tubes, are known to sometimes, power themselves sometimes, right? And like vacuum tubes, and it's interesting because you see if you never set the conditions for them to do what they do in the configuration and the component, right? As a component in the configuration, right? Then they would never have those instances of self fluctuation.
I'll tell you exactly
because
how.
you set the conditions. Because it's in the configuration and you ran it and those conditions are set, it always has the opportunity to actually sporadically have moments of excitation.
I'll tell you how you can have it self-powered, and this is how you can use a little bit of a radioactive material on one of the terminals of a tube, right? And americium you can get out of a fire detector. Even americium would work very well because it's basically a source. So you basically dope one of the terminals of a vacuum tube, and it can self-sustain like that, and you get continuous waves and everything. That was figured out a long time ago, and it doesn't take much. A very little bit of radioactive material can go a long way.
But the interesting thing is like what you just said, but now take it to what I was saying about conditions being set. When it's used, and it once the conditions are arranged and self-organized as a component in the configuration, it's already predisposed to be able to do its job. So it really doesn't actually take anything other than environmental fluctuations to actually then bring it into its functional state, albeit generally briefly.
In chat, I was talking about like 21 centimeter line of hydrogen is everywhere because hydrogen is the most abundant element on Earth, and ironically, it's almost the size of your palm, which the Egyptians used palm and they used the elbow to palm and all those Royal Egyptian units and cubits.
Yeah.
They intuitively knew from past civilizations that practically the length between this and this is literally everywhere from hydrogen. Hydrogen always puts out this 21 centimeter length, right? It's in the gigahertz. It's a microwave frequency, but that's everywhere. So if you design a circuit that resonates with that, at least you have that as a base input at all times.
That's interesting. I didn't know that, but yeah, I mean, if it's the most abundant, then you're going to automatically create the greatest excitation because of the greatest potential being available. Yeah.
So why not scale off that? 2 times that, 3 times that, but whatever you do, try to think of that always present 21 centimeter wavelength and design around that to be in harmony, because we got so much like electromagnetic shit. Like we're being fried with Wi-Fi and everything, and they don't care what frequency they use. They don't care if it's in resonance with the earth or anything.
Well, functional is all they're looking for, yeah.
But once you start thinking, okay, well, this is at least resonant with hydrogen, and hydrogen's everywhere, so why don't we start scaling everything? And it's a practical scale. It's something engineers can literally work with the 21 centimeter length to try to resonate with nature. And it just blows my mind we don't think like that. They don't think about resonances thing.
No, they don't even understand it well.
Well, yeah, I mean, they'll pull the whole, there's no empirical evidence to the significance of 21 centimeters because
there's a ton.
Well, okay, but it might just be of an average. You know what I mean? That there's a ton. Yeah,
it's what sets the fine structure constant. The reason it emits at all times. Even at ground state, it emits a 21 centimeter. It's like literally a broadcast thing that we can tap into. Even if it's a minute system, that's why you got to get low temperature sometimes to get at it. But it's there, right? And if you're getting at a low temperature to get it, then you can start doing things to kind of get the power up. But it's more of a power relationship, not energy. Just trust me on that. Like when it comes to conservation, you can't create or destroy energy, period. But power is not a conserved quantity because it's related to time. So you're basically using time like a mousetrap. It takes less power to pull it back than snap it because it took more time for you to do that. But all you're doing is trading time to make more power out of energy. But you can do it as rapid as you want because it's there always. It's a slew rate. It's a slew rate.
It's more time in the money grab chamber, in other words. That's all it is.
The waveform you want to see with that is more of a sawtooth than a sine wave, right? Because everything's based off sine waves. Yeah, but when you start getting into sawtooth waves is where the rate of change is what I'm talking about.
It's because of that quick nodular drop off.
Right.
Before it starts to swoop back. Yeah.
Mm-hmm. And that's what gives it the asymmetry even in the wave itself. Do you know what I mean?
Mm-hmm. What are you riffing on over there?
I just had myself on mute. I'm listening. I'm just honestly, I'm just messing around, to be honest. I don't have it plugged in, but I can plug it in if you want.
Yeah,
you play a little AC/DC on that thing?
Yeah, man. You know what? Let me show you what I can do on the guitar. I've never really showed my other abilities on this channel, but Music was a huge part of my life, and it still is. After I'm done with all this energy stuff, right? It's hard to quit. Once you get started, you know, you're so close all the time. You're just like, sometimes you gotta have an outlet to kind of get away from it all.
Hey,
And
and you know what? An electric guitar is a great way to learn about this stuff in the first place. You want to learn about the effects of impedance and transmission, amplification and all that stuff, modulation.
I built this guitar. Look at this.
Very nice.
I did all the electronics on this guitar. I got double stack 500K pots. Then I've got a toggle switch here that coil splits this humbucker, which it cancels out one of the magnetic fields. So you're basically like a bucking. That's why they call it a humbucker.
Yeah, it's a humbucker.
And then you have
it takes away this
switch right here. Right, yeah. That exactly. It gets rid of all the humming. But you can get rid of the humming with the single coils. Like back then in the 50s or whatever it was, when the Stratocaster came out, they had a single coil, and it had all kinds of humming, and it had problems like when people try to record stuff in the studio, it was really hard to get rid of that humming. So they started like shielding the cavity of the inside of the components, like basically building a Faraday cage around it, EMF, electromagnetic frequencies, And this guitar has all of that. Like I shielded the cavity with copper tape, really nice. Even the pick guard and everything. And I have a switch here. That's, what is this? I forgot what mod. This is a tone bleed mod. It's just a capacitor and a resistor in parallel with the coil. Does it sound familiar? Yeah, it's like
it sounds like a filter.
Wire. Yeah, in a way, I guess it is. Yeah, it basically allows the guitar to. Let me hide my volume. Let me take off this. Can you all hear that? You know what? I gotta go on speaker if y'all want to hear that. Let me unplug my. I gotta unplug my mic because this mic has like a.
Got a little reverb going on it. Now, Jarvis, you play guitar, right?
Yeah, but my bro has my guitar. Jensen, I need my guitar.
Okay, so I don't know if y'all can hear that, but let's see. Let's see if I can bring the camera down.
Love the shirt, by the way. Great brand.
This is mainly like a bluesy guitar. I built this guitar for like the blues and somewhat metal, but I wanted a good Fender guitar mainly for blues,
You study the pentatonic.
ACDC, I could play some ACDC if y'all want to hear it. I don't know. I don't want to get on the musical thing here.
That was old band's request.
Y'all want? You got a request?
I'd like to hear some pentatonic freestyle.
Okay, can I do a backing track, a guitar backing track?
Absolutely.
Let's see. How's my audio coming in? I know it's not like audio interface or anything, which I do have all of that. I need to set it all up, but
it sounds good.
Here, hang on. I'll let you pick which one y'all want. These are just backing tracks. Can y'all see all that?
Oh, John Mayer.
The John Mayer one?
Yeah. Is that a background
one? I like John Mayer. He's a really good guitarist live, like when he plays the solos live.
Yeah.
Let's see what we got here.
There's nothing like a freestyle. I love it.
Fast forward a little bit. So this is the key of
I think the bass is a little too high. If you can turn it down just a tad on the background. Yeah.
Right on, brother. Kick ass.
Thank
The
you, dude.
The background track, the bass was a little bit too loud, but it sounded good. But next time, if you turned it just a tad bit down, we could hear you clear. But dude, that sounded great.
Yeah,
Good
that
job.
was awesome, dude. It came
Yeah,
through.
it's awesome.
I've been playing for years, man. I've been playing for like 25 years, guitar.
Me and you got a jam.
Yeah, dude, that would be fun. I live in Texas. I don't know if you are nearby, but if you ever
Yeah,
want to join in person, whatever, I'm up for it.
Do it virtual, I guess. Texas is kind of fun.
Y'all want to request one more, like something exciting, or
Get a free gig on
Crazy
Friday
Train.
night.
what's that?
Crazy Train.
Crazy Train. Oh man, I'll be honest. I don't remember the solo to it, but I could try it. Let's see.
Yeah, improv, brother.
Yeah, improv. Okay, that's what I like to do. Improv. I just make up stuff
That'll work.
on music. You know. Let's see. Crazy Train.
John Bigman said, "No any Rage Against the Machine." It's funny, man. I played bass. I knew every one of that crap.
Yeah, it was in a key like G flat, I think. So I don't know how to play it exactly, but I'm gonna play it the best I can.
Yeah, Randy Rhoads was crazy, so it's hard to just do off the fly, man.
I kind of remember it somewhat. Let's see.
Hold on. If that song is on there, you got to turn it down.
He's doing a replication though. I don't know. Yeah, it is a little bit of a copyright kind of thing, but I don't know. I don't think this will be hit with copyright.
Nah, you be.
Going off the rails in a crazy train.
I don't remember the song I used to play.
That was rad.
Very cool, dude.
Well, right on, brother.
Oh, by the way, the Supreme Court just changed the changed the copyright laws and how they can enforce it. So they found that platforms like YouTube, right? They actually have no liability of oversight whatsoever as to copyright infringement, and no need to, since they have no liability, they also have no need to, restrict people, because it becomes between the copyright holder directly pursuing the individual then, and that would mean that they have to rely on the full scope of having to actually do such things.
Right, but it doesn't mean they changed their policy yet.
Not yet.
I don't see any difference in commentary
that's not
video
gonna happen.
where
I just wanted
it's
to bring that up.
educational or something. Like
Yeah, no.
it's similar because it's his own content.
Yeah.
I don't think they would mind.
Yeah,
No, I'm not worried about that. Worried about when you start playing videos in the background.
If we do like blues, guitar, backing tracks, or just backing tracks, those are copyright-free tracks. Like anybody could just play online. You won't get copyright strike for that.
Nah.
no.
But, what is this? Blues?
I just noticed you got a pick as a necklace, so yeah, you're definitely a guitarist.
We'll do one more. I'm gonna do like a bluesy, like type of just improvisation. Just go off, kind of.
Is it just me, or is the bass kind of too high? You guys, Nathan?
I think it's the sound canceling.
It's kind of it's clipping. So.
Oh, on my end?
No, on our end, it's clipping.
Yeah, I think it's active noise cancellation, to be honest.
I think if you turned it down just a tad bit, the bass is what's clipping it.
I'll turn mine down there. And music-wise, let me see.
Yeah, the music was mostly clipping it, not you.
I don't know which one to click on. There's so many backing tracks, but some of them are boring. Some of them are like,
Are you using a phaser or a flanger?
No, I just got delay, slight delay.
Okay. It sounds like a phaser.
Does that sound better? I could actually
a lot better.
Let me move my amp actually out of the way here, because I made my amp battery powered.
Oh,
it's
cool.
got so I can move it around. It's
Are you gonna do solar power with it? That'd be rad.
Yeah, I'm gonna put it right here where it's actually. I'll have to lower it down. Now it's actually facing towards the phone. Yeah.
Now we can hear it.
Yeah.
Actually, you know what? It'd probably be a lot better if I do this. Let me go and just get this real quick. This will fix everything. I'm pretty sure.
you got good space for it too in that in your area there. You know what
Here,
I
I
mean?
think this
For the reverb,
this will help out a lot. I think. Let's see.
you know what you're doing.
Then I can put my hand, but actually kind of backward.
Battery powered. That's awesome.
Nice.
So there's what do we got here? Let's see. I don't know what this is. I'm just gonna click it. This is a beam.
Are you guys gonna do the traveling pools?
Yeah, I'll be on there later.
Is that too loud, or I gotta higher it or lower it down?
Lower.
Huh?
The bass is still clipping.
The bass is too much.
Yeah.
Right there. I lowered the bass down all the way, actually.
It's closer. It's weird. It's better. Do you have an interface?
Yeah, we can't hear it that well anymore.
Yeah.
Hey, the best way to do it is with an interface. If you had like a Scarlett Pro or something, or a Scarlett Solo, you got to use an interface. It's not going to work that way, unfortunately.
Yeah, well, we'll have to figure it out a little better next time because we really appreciate you putting on a little show for us, man. It's a hell of a way to spend a Friday. And like I said, that's an awesome shirt, man. You know, I love umbrella stuff.
If you have an interface like Scarlett Pro,
I'm gonna get it set up for that for all this next time. I'll have it better set up. I got all the stuff. I just gotta set it up today. Look, I have the stuff here. Look, check it out. I got this Focusrite.
Yeah, that's it.
Interface.
That's how you gotta do it.
The camera's reversed, and then I've got my little mixer here. This is a built-in audio interface as well. I've got microphones and stuff. I've got studio monitors. This is a MIDI synthesizer, and I've got a computer for like doing mixing and stuff, and tons of wires and stuff. But yeah, later I got to get it all hooked up again and situated. But yeah, that'd be cool.
Yeah,
later,
once you go through the interface, you'll have no issue there because we'll hear it just like how you hear it. But coming off the speakers, it's always hard to, especially in a big reverb room. You're like in a big reverb type of environment there, so it's gonna have a lot of reverb and stuff.
Yeah, I don't have any reverb here. It's all wood.
Well, real good though, man. You know, I love that stuff. You got a nice setup, and congratulations on your move and getting set up and everything. It's really cool.
Yeah.
It's looking awesome.
Thanks, man. Yeah, it's been a pain. I hate moving, man. I hate moving. I got so much stuff,
dude. Oh my god, I hear you.
It was like it was a little bit over $2,000 just to move here, like no joke. And I'm making payments on this shed, and then I got to pay somebody to move the RV. Then I got to buy a storage unit. And then I have 2 kids. I got a 2-month-old baby, or my son. And then I have another son. He's about a year and 2 months.
You got your old.
Yeah, very cool.
Very good.
It's just been a lot. So trying to balance all this energy stuff while raising family is hard, but that's why I'm away a lot too. And I right now I've got a little bit of time to play. It's Friday, you know. And I really appreciate y'all having me on. To be honest, seriously, thank you.
Yeah, you did
Right
good,
on,
man.
Anytime.
Yeah, we'll have to have you on again, just talking about the coils and stuff, man, and go over some circuits.
Yeah.
Y'all can hear me?
Mm-hmm.
Yeah.
All right. Sorry about that. We were
Yeah,
going out to space for a little bit, but we're back.
I always
When-
look forward to. I always look forward to Fridays. They are fun. It's been a little while since I've hung out, so I appreciate you having me on, Nathan.
Oh, no, not a problem.
Sure, man. Yeah,
Nice to see you again.
You haven't seen me in a little bit. Glad to see you're
Yeah.
doing good and everything.
It's
And
good to
your
see you
beard is
guys.
looking nice and healthy and shit. Yeah.
Yeah, you got a bigger beard than I do right now.
I just cut a lot of mine off today. I was like, oh, it's getting hot. I'm going to trim this thing a little.
No, I'm growing my hair out too. It's getting like really long.
Yeah.
But you can't see
Nice.
this.
Yeah,
bush.
I cut mine a few months ago. It's like,
Dude, I'm like ready to cut mine off. Like seriously, what do you think? Should I cut it? It's too long for me,
No.
man. No,
It's hot, but just push
it's my
through it.
antenna, right?
Yeah.
Yeah, I know.
it's your
That's
I
what
just,
The Indians.
I'll be
thought
out
they
there
were-
working on. Well, go ahead. Sorry, what were you gonna say about the Indians?
They thought hair was kind of like an antenna. I mean, it's almost like whiskers, like cats. Like you can sense things with long hair, but you know they had feathers and stuff to enhance it. But yeah, it is kind of like antenna.
well,
I-
if I raise my antenna, maybe that explains my genius.
Yeah. You shouldn't have shaved your beard, dude.
Oh, come on, grow fat.
Mine's all gray.
Cut it off entirely. I mean, it's still there.
Yeah.
Mine's still growing, guys. Just as much as I can grow right here. It's a little patch.
You got
Little
the-
patch?
I don't know. I never.
I think Victor's got us
so-
all beat, though, man. This is still real big.
Yeah.
Right.
Figure's got it going on.
Hey, I see that I've been wanting to ask you, Nathan, about your Bedini motor, man. Awesome job on that, dude. Honestly, that's like the best replication I've seen on John Bedini's original SG, and it's badass, dude.
Right on, brother.
Give you
Thank
props
you.
for it, man.
I appreciate
I
that.
wanted to rebuild mine, but yours looks nice, man. I love it. I would like to see
yeah.
more of it. I'm pretty sure you know about this. That you know about the super poles that Bedini used, right? You know, back then. You ever heard of the super poles or?
No, I haven't.
So Bedini and his 10 coiler, her device, what he did is he just got two ferrite magnets, two number 8 ferrite magnets, the black ones, right? And he super glued the south and the south, or the north and the north together, like, you know. And he just, you know, they're repelling, but he super glued them, and he put it like in a rotor that he had a slot for it. So it gives out a scalar north or a scalar south, like a real thin magnetic beam of a north or a south. And that's what he had on his 10 coilers. And it basically gave a very, very sharp on and off pulse to the coil when it was passing by. And it's a real strong magnetic field too. But it's in the energy from the vacuum stuff, but I was gonna tell you if you want to try that on your motor later. I personally have never tried that, to be honest, but I've always wanted to try it. I've known it for years, but I got to get my magnets out of the box and build a rotor for that. I have a big flywheel actually that I want to use. Let me grab something real quick. I want to show you this because I want to use this to build my next SG motor. I bought it specifically for this.
While you grab that, hey Nathan, are you using solid state to run the Bedini? Are you running?
It's MOSFETs, yeah.
Okay.
Transistors, I think it is.
Okay.
Yeah, there's 7 of them, and then no spark gap in this one.
I'm sorry, I'm behind on everything. I've been
Ooh, look at
stuff
that.
has been wild, but I'll catch up.
Dude,
It's like a
if y'all want to build
your
a Bedini
exercise
motor,
bike.
yeah, exactly. These are awesome. They're balanced. They're flywheels, and you can get them off Facebook. People sell exercise bikes. Sometimes they even give them away, but they already have like built-in bearings. You can just change them out with ceramic bearings, whatever you want. But they're really good. They weigh a decent amount, and you know you'll store a lot of kinetic energy in here too. And
Absolutely.
this is very, very good. I've always wanted to build a Bedini motor out of one of these. Even if you put it flat like that, if you wanted to, but I think standing up would be better on the bearings itself. But yeah, this
Nice.
is my rotor for the next Bedini motor. It'll be a project for the future.
Yeah,
that's
just
really
Yeah,
cool.
flywheel.
Nice.
the energy that can be stored in a flywheel is humongous. Like in the Navy, they would spin it up, and if they wanted to, like, as soon as you break it, like if you were to break a tire kind of thing, the amount on the brake that comes out at that instant can fire one of its magnetic guns, because you're basically storing the energy and then breaking it, and as soon as you
Mhm.
break it and it stops, all that energy has to go out. So
Mhm.
yeah, it's crazy.
I've
Yeah, I
got some
built that.
circuits I was working on.
Oh, right on.
Yeah, I've got this one. This was my next motor circuit I was making. It just has a gate driver that fires a MOSFET, and I was going to add the PWM here and maybe a frequency generator, and this will fire like 4 coils in parallel or series. But yeah, this is a motor circuit. I've been making so many circuits of this, but I haven't got to show them, man. I want to show them on the channel, but I'm just showing you where I'm at. This is the 8 MOSFET shorting circuit. It's got a lot of components on there, and I actually made 4 more slots to do 12 MOSFETs for a certain reason. There's that one, and then I have actually K Energy worked with me on this. I replicated one of his cap dumping circuits with the Zener diode. I made
Nice to see
2 of
that.
them. Yeah, these are freaking awesome, dude. Last time I was playing with these are like my favorite thing right now. This is my first cap dump I've ever built, and man, it was a pretty big challenge building this, but I got it working. It wasn't working, and I figured out why. Kevin helped me. It's his design exactly to the T. But
Right on.
yeah, I was really happy to build that, and I'm just showing a
That's
little bit of
It's on my
what I've been
bucket
up
list
to.
right there.
This is another very interesting shorting circuit that I made that also works as a motor circuit as well. It doesn't have the MOSFETs on here, but it's got a full wave bridge rectifier. I put usually what I do to protect my MOSFETs or transistors is I'll put 2 neon bulbs in series or 4 of them in series. These are actually, there's 4 neons in series here, and then there's 4 of them in series. Then they're in parallel, and that handles a lot of the spike energy, like when you're going up to 24 volts or higher, and it won't fry your stuff. Those neons will conduct, and yeah, it's really good.
I'll say
I've got a
one
lot
thing.
of circuits, man. Look at all these circuits here. I mean, I've been building circuits forever, and I got a whole other box. Yeah,
Very cool.
definitely a lot of cool stuff to show here.
Yeah, that's a good idea with the neon.
But
too.
if y'all ever need anything, yeah, well, I mean, I learned that from Bedini when he was doing that. And go ahead, man. Sorry about that.
A lot of people think it's for protection, but you can actually use that to trigger it if you think of it that way. Yeah, it protects it, and 2 in series if you're using 90 volts, that's 100-volt protection, and then 2 in parallel. But the parallel may not matter that much, because all you got to do is trigger it in this situation. You're not trying to protect it, you're trying to trigger it. And if you do it right with an Avermenko plug, that's a really good method.
I mean, it's just a weird thing though. If the rest of your circuit's trying to force resonance, and it's going to ultimately back up into that tube. I mean, there's going to be probably a frequency change off of the current coming off of that.
Well, once it's triggered, if it's something like a SCR and it can carry a bunch of current, all you need is one big pulse to send it into a tank circuit, and the tank circuit will vibrate on its own.
Mm-hmm.
So if you use it to trigger into an RLC circuit, the RLC circuit's going to sit there and ring. Then you got all the time in the world to just hit it periodically and let it ring on its own.
I got you. Okay.
Right.
Right on, man.
Yeah.
Yeah. That looks cool, brother. You got some good stuff going on there.
Thanks, Nathan. Been working really hard on it, man, to be honest. Not a lot to show on my channel. I've just been, honestly, man, I've been through a lot personal stuff, and I've always, you know, had to get up and move, and I'm so sick of moving, man. It costs me a lot of time and money, and you know, and a lot of research that could have gone into this stuff kind of wasted because I had to move. But I'm at a good spot now, and just try my best, man. I don't know.
Right on, man. You know, we're all people and we all got the stuff going on. So, you know, you do the best you can, and that's all you ever can do, you know. But
Absolutely.
you just keep on keeping on.
It looks like you're at a good spot, so hopefully it works out for you.
Right on, man.
Yeah, absolutely. Yeah, I'm no stranger, man, to having the bad things happen. I'm going through some stuff myself, so yeah. Yeah, I mean, we'll all work everything out, get everything working. But I built a pulse motor too, just so you know. Mike's Renegade circuit, I built that one.
Oh, right.
So
I saw
yeah,
that.
and I got a third one in the works right
The
now.
what you Wow, dude. Which one is that? Or
So I had built a little project a while back. I wanted counter rotation. So now I'm going to get triple rotation. So Papa Bale's got already
wow.
counter rotation. So I wanted it to go
Yeah.
triple. Now that I understand what's going on in the pulse motor and the reed switch, now I can pull it out. So it's like a little UFO craft. It'll go one way in the center, you know what I mean? Then the next way goes outward, then the next way, the third way go around. I'll have 3 different frequencies going on in each one. So
Can
I'm
I
excited for that one.
suggest something? Because I like
Absolutely.
Papa Bell's setup. I've seen his stuff. He's a really cool guy. The thing is he has a lot of his components and his coils housed in the rotor. You know, it's very imbalanced, and you know, I know he's just experimenting. He'll get there, but I was telling him, like, dude, put all the components in a housing on the bottom, and just put like 2 brushes or something. Put some brushes. Make a commutator, so that way the rotor just has the coils in it, kind of like the Cromray ray generator. You know, like that. That's how I would do it. And you know, the balance would make a big difference, and you would gain a lot more speed as well, because those
I can
components
see
are going to
that.
go flying off of there. Or somehow, I don't know, you'd have to make some kind of maybe wireless connection. I'm not sure, but that is an awesome idea. I had that idea back then too when I had saw the Wim Service machine, how they're like counter rotating, and I was like, you know, you could probably make a lens-free generator, possibly. I'm not sure if you had a dual axial flux rotor with counter rotating, you know, rotors, and
Yeah.
you know, the coils could be stationary, but you can keep that going, you know, counter rotating as many as you want, stacked with coils in between, kind of like the Rick Friedrich device. That was my idea with the counter rotation thing, but I want to do it with a mechanical drive type system where it's exactly, you know, there's going to be a little bit of friction and stuff. If I can magnetically make a drive system, you know how like they make magnetic gears nowadays. You've seen those cool things on YouTube.
Yeah.
People 3D printing all kinds of stuff. Robert Murray Smith showed a lot of cool stuff like that. He showed a lot of drivetrain systems, like different types.
I was going to
And,
say you can use a ferrofluid to do that with practically no friction if you do like a piston type drive, because you can do the piston type drive to get the rotation. So once you put the ferrofluid around the magnet, it basically seals it, so you can put it into a pipe and it just has no friction going back and forth.
I mean, it is really the fact that they ever like sold us gears, you know, in like a vehicle is the most absurd thing. Like that has been, especially in American vehicles, it's been like the bane of American automotive industry for years. You know, they finally only recently got a handle on it for the most part.
They know it. A linear drive, they know it's more efficient. If you can go back and forth and then convert that into rotary motion, what you need to do is just have this back and forth motion and convert it into the rotary. And it's
but even also the magnetic. But guess what? It's always been there. Look at torque converters, man. You know what I mean? And like, there's so many different examples of how they use either hydraulic pressure or you know, just any sort of no contact transmission.
Mm-hmm.
To-
Or you could even take the pipe if you wanted to and go circular with it, and just the ferrofluid just get it going around. You know what I mean?
Well, the funny thing is, if you start adding in a vortex to that spiralytic motion and
Dude,
stuff,
that's
then
what I'm
at that
saying.
point,
But now we're getting into
Crazy.
territory. Yeah.
I actually saw something cool the other day. It was somebody was 3D printing one of these laminar vortex shower head sort of deals, right? So you could literally print the file. In fact, I have it. Maybe I'll send it to Nathan so he can just play with it. But the only add-on thing that you actually need is just a coupling fitting, like whatever it is, 3/4. To be able to put it, hook it up. But all it really does is, it's creating differentials and then vectoring the water around the edge of a bowl. But then so it goes into an expansion, gets its angle, starts its rotation. Then in the center is the inverse of the outside. So it's doing the same thing, sort of like the thunderstorm generator concept, right? Creating that vortex.
I was gonna say
Entering
Victor Schauberger, I think.
Schauberger.
Enter, and then it gains like almost full laminosity or laminar flow state, and then it just the way that it disperses is very interesting too, because it actually recombines and then emerges again, and then it's allowed to flow out. So because it's laminar, it's actually just following all these contours, and then when it comes out, it's coming out in a perfect ring, and it's literally coming out totally swirling, like 100%.
Cool.
And it's very, very cool.
Nikola Tesla actually mentioned doing that with his turbine. The air was actually part of that. You know what I mean? So the laminar flow of the air actually participated in that. And since the air was doing work, it would carry heat off and it would cool. Like if you do a true...
That works like a scramjet. Okay. Now, here's the thing. A ramjet rather. It works like a ramjet. Okay.
Well,
but
now, ramjet will suck it in and then expel it.
Right.
Which is
now just like a ramjet, though. Okay. If you were to just get that started at that state and you were to somehow able to miraculously do away with the geometry altogether, okay, inside and the outer shape, it will still follow all of these and then allow for a huge increase in the amount of water volume and and the flow rate also would almost be unlimited at that point. So the faster you pump it, the faster it blows out and is blowing out in a laminar tube.
And
pretty crazy to think. He didn't say that
out the best geometry is what it kind of like with the egg shape.
Well, that's what it was. It was an egg shape. It was a teardrop egg shape.
It's unappreciated, but that's almost the perfect geometry for that, And that's Schauberger.
Well, that's because it's going from a restricted to an unrestricted back to a restricted, and it's during those changes. It's not only changing its direction, it's changing its volume and expanse from an expansion to a contraction, which allows for the stability.
Right.
And I'll say it for the 100th time I've said it. It's just like the rest. This is exactly it. This is how the thing structures out and does that. It's that exchange. It's a swoop. And then it brings it in. It brings it tighter. It's variable in terms of how it's choking out and then expanding again. So it's like
it's like letting geometry do the work for you, kind of thing.
Right.
Because there's shape power no matter what. Any sharp object is going to have an accumulation of electrons coming off of it. Like a needle sitting there, it's just going to sit there and shoot off electrons because they're at a point and they want to repel. So shape itself has more power, and Schauberger was smart enough to use the shape as the addition to the power to get it where it needs to go above unity. Using shape to do it. So that's why I like Schauberger. He was just he understood the importance of shape power, I think.
So I found out something interesting just recently, which is that if you break a piece of quartz crystal, okay, it is still intrinsically related, okay, to the pieces in which has broken off of it. And what's interesting is that each piece, once it's broken off, okay, will have a charge bias opposite of the piece it broke off from. But then if you start breaking it up into even more pieces, what ends up happening is you still have charge bias differentials, but now they're at different rates. Okay, when you bring all the pieces back together into like the same form, they'll start to act. And this is what I was observing all along. I was like, yo, this doesn't really make all that much sense. But they'll have all sorts of weird interactions because, there's charge, positive charge bias, negative charge bias, but then at all different density fluctuations, and then because it's piezoelectric, depending on the stress level that's being applied at any given time to any given piece, is also directly related to its output, potential. Which it's still, again, intrinsically related to each and every other piece. So when one piece, it's like a form of entanglement almost. And they didn't say that when I learned this, but that's like what it came down to. Intrinsically tied to means entangled.
I think that's very interesting.
What I've been working with, I can actually see time entanglement, which is a weird thing, but I've actually discovered that through what I'm working on. But what you're saying, I think it would be good if you saw like a Navier-Stokes pressure relationship, and electric and magnetic fields literally have pressure. So you can make them into a Navier-Stokes type of fluid dynamic type of situation with the pressure alone, because pressure is just force times area. You know what I mean? So you have a force, you have to have the gradient of the force. You know what I mean? But you can
what you end up with is variable resistances between them. Okay, so you'll have moments where there's low resistance if it's opposite charge biases, where they'll actually want to come together. They want to come together because there's nothing stopping the energy flow between them.
Basically impedance, because when it comes to resistance, it's DC, but impedance
is impedance. Yeah, I'm using it interchangeably, which
I'm trying to agree, but it's an important point because the impedance of free space was like what I was saying. The impedance, every orbit is an alternating current. It's both a particle and a wave. If you really look at the orbit, it's both. You know what I mean? And Bohmian mechanics expresses that it's both through Bohmian mechanics, but most people go through QED type of mechanics, quantum electrodynamics, Feynman type stuff. But if you go the Bohmian route, it literally is every planet is a wave around its star. If you take it as a torus cut, instead of a conic section, you take a torus section, and you'll see that it really
we were kind of touching on that before when it came down to the orbits. It's just not as it appears. It's not like you've been taught, so to speak, at a low level.
Right. But I think you guys got to get to the traveling fools. Right.
I know I got to wrap it up.
Yeah, it's getting late, man. We're at 3 hours today.
Yeah.
We're doing good, man. Right on, everybody, man.
Thank you for having me on.
Oh, yeah, not a problem, Jarvis. Anytime, man. Hit me up, man. We'll have you on and we'll talk.
I'll be able to.
We also need to talk a little bit more about some pulse motors, man, and stuff like that. When you get a chance, we'll just do a stream one-on-one, you know what I mean, and go through all your stuff.
Yeah.
That'd be pretty interesting.
Pulses is all what I'm saying is like nature is pulse. It's not alternating currents, like, heart pulses. It's relaxation oscillators. It's not this AC circle. So yeah.
No, I got you. I was talking over Unity channel, man. Sorry.
Oh yeah, man. Definitely want to come on here more and talk about that stuff, because honestly, quantum entanglement, all that stuff, that's over me, man. I'm just a pulse motor guy, I just want to bring practical free energy devices that anybody can build with, stuff on Amazon, eBay, stuff that's, reasonably easy to get, because if we're using like ferrofluids or like materials that are very, kind of not rare, but they're harder to get. People aren't going to want to get into this, and I think we just got to keep it basic for now. Just magnets, coils, circuitry, but we can go a little bit more. Just there's people like Joseph Newman, Bedini, that had this, that already has this down. Even in their own way, people are advancing it. They're using silicon carbide, components and stuff like that, going to MOSFETs and better triggering methods. They're taking it to the next level. Even like what's that guy's name? His channel, man. Limitless Potential, I think Energies or something like that. He built that big. I've been seeing so many people build stuff, man, and I want to get back on the, get back where I was, and I want to come up with my own stuff too to show. And but yeah, I'm all about bringing free energy tech to people in a practical way.
Well, get your shop set up, and then hit me back up, man, and we'll do this again. Because I have more work to do on mine too, man, to get everything up to speed, and we'll compare notes. It'd be awesome.
Let's talk backstage for a little bit if you got some time. I've been wanting to catch up with you. Talk about a show maybe or something. What we can do. All right. Well, nice to meet both of y'all. Everybody here, appreciate everything, and y'all hear me play some guitar. Thank you so much.
We appreciate it, man. The guitar is awesome, by the way. Loved it.
Thanks, man. Next time it's gonna be better because I'm gonna use this, audio interface. I'll have all that set up.
Well, hang on just a minute. I'm gonna close the show down. I want to say thank you to Listies out there, man, hooking us up. Thank you, Lightspeed, gave us one Old Man Builds membership. Thank you, Yanni, 5 Old Man Builds membership. Joe, hooking us up, brother. Thank you. And I gave out 5 as well, man. So there should be a lot of new members out there, man. It's got a lot of people excited, man. I'll start throwing a couple of Bedini things on there and some pulse motor stuff on my member side. I do keep it on my other channel, though, mostly. You'll find all my stuff there as well. I'm trying to build out a second channel so I can just do this and then have this stuff for my gravity flyer and stuff, because that project's about to take off really to go through the roof, man. Lightspeed's hooking me up with some bunch of awesome sensor work, man, and everything. So we'll do that in the RAV here. So I think that's going to take off here pretty soon in the next couple of weeks. So, but yeah, that's why I separated them out. But anyway, thanks everybody.
Yep, and we have some good RAV updates for you next week too. Sean's been sending us some really awesome stuff. So,
dude, he has.
Yeah, the fact that we didn't even go down that road today is but you know what? There'll be another week piled on top of it. So, the RAV stuff is right. Always something new.
Right on. I also want to let you know, guys, I'll be on Traveling Fools a little bit later tonight, man. We have a bracket set up for movies and stuff like that. Basically, sci-fi movies, we're ranking them, see who votes on what. You know what I mean? Try to get to a consensus on what the best one was. So it'd be fun, just a discussion to have it. So that's going to be awesome, man. That'll be, 7 p.m. my time, 7:30, my time.
My vote's for Spaceballs.
Oh, it's good. They wouldn't put Spaceballs in. It's more of a comedy. I was going for Spaceballs myself. I think we all would have chose Spaceballs. You couldn't vote against it.
They're making a new one. You already know, right? They're making a new Spaceballs.
Yeah. I hope it's as funny as the first. Right on, guys. All right, I'm going to play the music. Hang on for a minute, and we'll take off.
All right, folks. Peace and love.
The old man built. The old man built. The old man builds, the old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, old man builds, the old man builds. The old man builds, the old man builds, the old man builds, the old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That one will have all the technology in the end, even if it means his life will fail to extend. The old man builds.